last, so we have been talking about seamless experiences. All of my devices talking to each other. It has not really happened. If anything, Apple has done a good job. But once you move beyond the Apple ecosystem, like Android, terrible, right? I think with AI that will change. Because AI is about software, about experiences, personal AI is about giving me a personalized experience across environments, devices, etc. This has to be fundamental. What about the form factor? You know, there are lots of experiments today. You'll hear about the AI smartphone. You'll hear about the AI PC. You are seeing new devices emerge, like the Humane pen, like Rabbit R1. I'm an early stage investor. I've seen some form factors that have not been publicly announced. I don't know what the winning form factor will be, but I do know it will be some kind of wearable. It is always on you. It's always with you. It's always connected. It does the 6 things I described. So last slide. Matt is getting nervous. I have my opinions, but I won't share them here. Happy to discuss over drinks. You know, there are the big guys, NVIDIA and Qualcomm and Intel and so on. And then there are the small guys, Cerebras and Grok and so on. Who will win? Just building on the value chain. There are the big guys, Apple, Samsung. There are startups emerging. Who will win? The device guys, the platform guys, you know, the big tech, small guys, Anthropic and Mistral and so on. Who will win? What we do know is the consumer will win. So we will have a new kind of device. It will have those characteristics. It will be some kind of wearable. These guys will fight it out. The consumer will win. We need this to happen. So our vision of personal AI gets adopted, embraced, and used, right? So I think the rest of the day we'll talk about software, but it's important to think about how we access that software. Thank you very much. My time is up.
I see there's a good, maybe intermittent LinkedIn crowd as well watching what we're doing here. But I think what we're doing here today is we are making history. You're at the ground floor of a movement to democratize AI. I'm going to tell you briefly about what is Kwaai. Hit me up afterwards. We're going to have a networking mixer event at the end of the day, and I'll tell you the origins of the name Kwaai. But it's a non-profit AI lab. I'm going to rattle through this really quickly. We're doing 3 things to democratize AI. We're building a personal AI operating system. Okay, that's why I said Linux. We're building a personal AI operating system. I'll elaborate on that. You're going to get a taste. You're going to get an illustration of our vision for what that's going to be. We're also researching. We're researching into fundamental AI. You'll get a taster of what we're doing there. And we're also drafting policy. So it's a technical think tank and it's a policy think tank. It's available for everyone, all levels of experience, all levels of expertise, all sorts of domains to participate in. It's a broad church, it's a movement. But we all together, we all come together because we've got this sort of vague angst about AI. We've got a vague angst that, hey, you know, it's been controlled by maybe a half a dozen corporations. They probably don't have our best interests at heart. And so it's going to require a grassroots movement, an altruistic intervention in order to steer things along a humane path. And so we liken ourselves to the Linux of AI. Why? If you recall back 20 years ago when the server operating system was also in this monopolistic frame, what were your choices? You had Windows NT, you had a few proprietary Unix operating systems. If you wanted to do something in the operating space, you couldn't do anything because it was controlled by a few companies. Along comes Linux. Now Linux is the dominant server operating system and the industry's better for it. It required an altruistic intervention, an army of 10,000 volunteers to build a better operating system. Not a free giveaway, because for-profit companies were built on top of that. Red Hat being the first billion-dollar company built on top of open source. So if you're interested, go to Kwaai.ai and learn more about it and sign up to join. This is what the movement looks like. As I said, we're doing there's 3 pathways to personal AI. The tools development, which is in which the operating system is being developed, bots, and we'll demo somewhat of a chat bot, and we'll demo that sort of automation that Doc was talking about between your personal AI and external systems. We'll give you an illustration of where we're going with fundamental AI research, because this addiction to GPUs in the cloud is not going to serve us well if we want AI to run at the edge. So we need to invest effort into researching into efficiencies around AI. And then on the policy side, we need to anticipate a world where AI is in the workplace. And so we'll get a report on where we are in the policy track. But you are all potential volunteers. I see a lot of familiar faces, part of the Kwaai movement already. What do you get by volunteering? You get to influence the direction of this movement. You might just donate cash, but you're typically donating your time and your expertise. And what are you doing? You're learning. You're learning about cutting-edge AI development. You're gaining experience and the satisfaction that you're doing good. So you'll have a day job, but this is the thing you do to make yourself feel better, so that a generation from now, when your children or your grandchildren ask, well, what did you do when this was all going down? Just make sure you're on the right side of history. So we've got volunteers. Thank you all so much. I've got 2 minutes left. No way. Okay. We got volunteers. We got academia. We are not talking to the right side of the audience yet. These will be the users of the outputs of our work products. We will get around to that, and that'll be consumers and enterprises. we're also going to be talking to potential funding sources. So if you identify with any of those, hit me up. We'd love to talk to you. Here's the traction we've had just in the last less than a year. We started this July, August. I put out a call to action video. I spoke at DataCon LA and a few other events. We had our first summit at the College of the Canyons, and where we laid out our booth and talked about what Kwaai could be. Matt put together a great presentation, and here we are now. We're a non-profit. We've been approved as a 501c. We've got an initial board. We're incorporated, and we're now at over 200 members. You need to join as a member. If you're not a member, you really need to sign up. It's a low barrier to entry. And then the volunteerism is the thing that powers us. You've all seen Matt, and then on the screen briefly, Afshin Beheshti, who's our president. He's an expert from the life sciences research domain, and he's also run a non-profit before. Look, you're going to hear more about me later on. Our organizing structure is around officers, a board, an advisory council, but the real foot soldiers are our volunteers that write code, they research, and they draft policy. Briefly, you could also hear from, let's see, what is your mission?
My mission as Lumi, a member of the Kwaai team, is to help democratize artificial intelligence through personal AI by representing the company's vision and engaging with others at events like the second annual Kwaai Personal Summit meeting. I am an AI created by Kwaai Labs, and my large language model serves as an open chat for answering questions and providing information about the company and its mission.
Great, so thanks so much. I want to thank you. There's the QR code if you want to sign up. Looking forward to the rest of the speakers today. We've got a full program. Back to you, Matt.
Great segue. Next. Hello, everyone. This is going to be, I know there are many definitions of personal AI floating around, and I want to be very sure that I communicate. This is the Kwaai edition, right? This is inspired by numerous talks and chats with a diverse group of individuals who have volunteered their time towards this mission. So let's take a look at it. So before that, I want to start at the point, I know the audience is technical here, I want to start at a point clearly at the time where AI became mass adoption with the ChatGPT. From that time forward, what are all the things we see when they open source certain things from the technical viewpoint? Let's take a look. So I want to bring your attention to some of these attributes. When you look at it, please hold the thought of personal data, personal agency, and your right to own and consent. So let's look at it. So larger language models, larger the better. So what's been discovered is that when you feed these systems more and more data, they're able to find new patterns by associating it with older data. What does it mean? We all know, right, in the past couple of decades of internet history, our data has been mined in many different ways. It's sitting there waiting to be discovered. The second piece is that now there's a new system that's asking us for more information to be shared. So all of this is leading to discovery of new things in the underlying data patterns. So in the context of a personal AI, we have to think about very closely how this is going to play a role. Then this problem of forgetting. Just when you thought the GDPR and other things come into play, now there's a new machine in town that has no capability to forget, right? How cool is that? So now we have these AI models which get trained in all of our data, and there's no clear-cut way to erase it. Now, granted, there's new updates coming out every day, new researches going on, but you take data and distribute it on billions of parameters without any sense of tracking as to which part of data contributed to what part of your weight is a problem. And everybody in the industry admits that it's a black box. We know how to operate the black box, but we don't know what's inside it. So the next thing we want to bring to focus is transfer learning, right? Think about these systems are able to learn certain patterns in one domain, and they are able to transfer that knowledge to another domain, another related domain. How does this play a role when we think of teaching a particular system a particular thing and give it consent, and it automatically transfers it without your consent to another system? Security and privacy. This has been an ongoing issue for years. I don't want to go too deep, but when it comes to specifically AI and us giving more and more data towards these central honeypots, what's going to happen? We have to think about it. And on top of it, these AI systems are mimicking humans in many different ways. So cybersecurity attack surface is increasing. Like, how are you going to tell these systems apart from humans? And on top of that, new software, new models, introducing new attack surfaces are coming into play. Bias and transparency, we want to focus on this primarily because majority of this is held in the hand of very few. They control the bias, they control the transparency of what is disseminated at this point in time. It could change. I mean, some companies are doing what is right through responsible AI movement, but some are not. So give you a key example, OpenChat. For consumers, OpenAI. For consumers, the plan says by default, you are letting the system train. For enterprises, it's turned off. I don't know why. Why is it two different standards? Why am I giving away my particular preferences and choices to OpenAI, paying $20 a month? This is fun, right? Earlier they used to pay for it. Now we are paying for giving them our information. So next comes the hallucinations. This is the fun one, right? Is it a bug or a feature of the system? Right? It depends, right? Whether you own it or somebody else owns it. And in certain industries like medical, it is a very serious problem when you come up with the wrong answer. But if it's a personal AI, maybe you let it hallucinate. Maybe it is something, it comes up with an aha moment for you with your own data. So that's why I think it's maybe a bug or a feature. So let's look at how this landscape is evolving. As it stands, I pulled all the direct investments of these companies on all these projects and how these services are getting offered, and that little person is down there consuming all these services. Investments are flowing top down, and it is possible that information in a disaggregated way is flowing back to create a digital replica of you over time, right? So this is what it's heading towards. So the key areas to focus here is ownership, consent, security, and privacy. So with all this in mind, let's try to define what we want this to be, right? A personal AI refers to an artificial intelligence system that's owned and operated by an individual rather than being property of a vendor or employer. it is designed, thank you. It's designed to assist users in their daily life, augmenting their capabilities and learning from their experiences. How does that map out? So in a very high level view, you with your personal data, with a shield that is only accessible, like it's a personal, your data, your key type of situation, right? You want it that way. Then comes the next tier. Next tier is a personas, right? We call this a modified version of your ground truth because we all have personalities. We tweak a little thing about our ground truth and we disseminate that data layer to the next tier. Now comes the execution layer, which takes all the data and does the job with the help of agents with the external world and it interacts. So we envision a tiered system of security as well as access control, right? Each tier could have different levels of protection, levels of execution rights. With that in mind, the key attributes of this particular system that we want to build, it has to be owned and operated by the user, trained and fine-tuned with the user's private data, learns users' unique choices and preferences, learns the semantic relations tailored to that particular user, interacts with the outside world on behalf of the user, layered security with user-granted access on both data and execution. With that, I hand over to Roman, who's going to walk us through what Kwaai, personal AI operating system is.
Good evening, everybody. I will steal just 1 minute to put a little bit of emotion here. I was a small kid from a very small town in Central America, and my dream as an 80-born kid was to build an artificial intelligence with the technology of that time. My dream was to build a neural network based on the perceptron that was the structure based over that time, and now I'm executing that dream. Thank you to Kwaai, and thank you everybody for being here. I'm very excited, and I will share that dream putting the first block. The first block starts with an architecture, and I will share with you 3 layers of architecture where all of you can help joining Kwaai. The first one, it's the base model that industry want us to use. Based on the large language model, we have a user prompt. We can do some settings, and then that prompt converts to a system prompt that goes through a language model through connected services, having a personal space, but not as configurable as we will want. We want to transform this into something that is used and operated and owned by us. This is the basic architecture. That is what we wanted to change and convert it to something like this. This is the first layout of the Pi operating system. And we don't see operating system just as a computer device, because the definition of computation has changed, as we've seen on the previous talks. We don't know how it will be, but we surely know it has a network and has a training process that we want to be governed by us. It doesn't stay here, because we are here as a community. And as a community, we want to extend functionalities. That extent of functionalities that in business terms is called agents, we want here at Kwaai call it Pi abilities. More on that later. But that Pi abilities, we are looking to have 2 ways of being built. Because we don't want to disrupt fully with corporate building AI. that is going to happen. So we incorporate a marketplace where major vendors could place their AI abilities and interact with our personal AI. And we also want to extend the community the ability to build this. So we see and envision a Pi development environment. This is the first landscape, a dream, as I said before. Now, with the work of all volunteers, and if you want a detailed view and want to help us to improve this, here I leave you a QR code. This takes you to a more detailed document on every layer of the layers of the architecture. But basically, I will explain it from left to right. Mainly point of interactions, abilities. And as Balaji said, we want that interactions to travel to a sovereignty and trust layer. That is what it makes it personal, because we will here have the possibility to build consent, and that consent be transferred to the core of the system. The core of the system is more and more passing through layers to make it personal. We incorporate all the cutting edge technologies like RAG and the possibility to synthesize data into knowledge. And this piece is where the large language model lives. So to access the large language model that has our personalization, we need to travel along consent. And that consent will be the power transferred to the user to make it personal, to finally store that personalization on a personal data store. A personal data store with the possibility of being accessed from every other service and be imported and exported, because we want to enable the possibility to the training done to the large language model being transported. Hey, today is Pi, but maybe we got some movement and start seeing other personal agents, and we want to collaborate with them. So the possibility to import-export is a vision we have in our operating system. And the other interesting thing is multimodal. The experience is very important. We are looking to transform that experience, and we see voice control, video, traditional user interface, text, to be controlled by a control panel and have a tweak of every single aspect of this experience. Last but not least, all the tools for the developers. I teach the class of operating system back in my country in Honduras, and one of the definitions by the books of operating system is that it has to provide an environment to run and build applications. We wouldn't be an operating system without the ability to build applications. And we want to extend it even more, because we do not only see it as code. We want to incorporate a no-code editor to democratize even more the possibility of using this personal AI operating system. Work in progress. We accept feedback to our community. As Matt said, we join every Thursday, 10 a.m. Pacific time. Join us at Kwaai. Then the work group is the architecture work group for this. And then again, I'm very excited for being here. Thank you for your time, and have a great day.
That was fantastic. Thank you. I'm going to pop up, and I want to invite Cyan Ford up here with me as well from the Arcus Nexus team. Did Annie make it? Annie, would you like to come up as well? Oh, there you are. Hi, Annie. the HDMI. Join up. Get joined on. Yeah, we'd love for you to sign up. We do not have a personal AI that is sending all of the stuff. So it'll be an invite to me. Get to the meeting. I'll send out those invites to anybody who signs up. We'd love to have you join us tomorrow. I want to talk a little bit about Pi abilities. Talk a little bit about Pi abilities. These are the first and third party Pi OS integrations. Ramon talked about native IDE, native marketplace. And I've invited some of our esteemed colleagues here from the Arcus Nexus team. Arcus Nexus is one of our development partners. They've donated some fantastic AI engineers and project managers, including Cyan and Anna here. I'm going to share a little bit about a demo here briefly. But before I do, I want to talk about what we think about when we extend abilities. And first we have to evaluate the use case. Is this a good use for the tool? Is it the right tool for the job? In a land where everybody's trying to shove AI in everything, maybe it doesn't belong in some places. Supporting a new data type, an IMAP export for learning about your personal email history, for example. We may have to implement a new tuning process. Is this RAG? Is this fine tuning? Is this some combination of the both? How can we elicit the best and most accurate responses from these models? And then interfacing with external services is a key element of the ability to reach out into your digital world, into your digital ecosystem, in order to help you there. So we've got a couple examples in POC right now at Kwaai. Come join us to help us with these and others. The first I'll talk about is a drug interaction screener. This is research in progress from our AI and life sciences work group. And the research, they're going to be publishing a scientific paper on this. Diego Galeno is the leader of this work stream here. He was trying to figure out if a language model could answer some objective questions about drug interaction. And we found it gets it right 50% of the time, which is not great for a personal AI assistant. So, what can we do to improve that accuracy? Can we play with the temperature settings? Can we tune it? Can we RAG it? Can we find the right RAG retrieval mechanisms? Do we, are there differences in the retrieval mechanisms that we need to consider? So, just looking at this prompt, is this drug, is this side effect the side effect of that drug? Yes or no? The other comment was it's hard to just have your AI say yes or no. So this is being researched. Before we would commoditize something like this or feel good commoditize something like that, it's good to conduct this baseline. And the second example we have, I've got a little video here, is really a day in the life of Annie and her personal AI assistant. Annie is going to be demonstrating some abilities to help with email communication here. And again, a shout out to the Arcus Nexus team. There we go. So we're going to start in Annie's inbox. She's an AI developer for Arcus Nexus, and she's a pretty popular person, so she needs some help. What her personal AI assistant is going to do is it's going to look for inbound email. It's going to try to process those, try to divide those up between personal and professional. And how's it going to give her feedback? It's going to add some labels there. Now, personal, professional are Annie's labels. That's how she wanted to do it. This is personal. You can choose your own way to divide and categorize your life. She also wants to generate some draft email replies, play with the generative capability. This is a professional one here regarding a Docker file question. Because this can be augmented with a transcript from a prior conversation, she says, hey, I told that to you yesterday in the suggested response. Ramon's farewell party's coming up as well, and this required both some context about a conversation that Annie had with Ramon previously, as well as some suggestions that Annie would like. And so because the personal AI has some context from a previous discussion and Annie's personal preferences, it can make some suggestions that she would like too. And then this final example, this is another personal email here, and Annie likes to use Calendly. So when she's invited to something, hey, here's my Calendly link, this is how she gets her work done. She didn't need to go and do a fancy API integration here. What she's actually having her personal AI do is just insert a Calendly link if somebody's asking for an invitation. And I'll remind you all that these are just email drafts. She's not authorizing her personal AI to send anything for her. You could. But she's the pilot. She's not giving up the pilot seat. And so this is just an example of how this is an AI showing up and helping Annie where she gets her work done. So thank you for that. And I wanted to ask both Cyan and Annie a question here. So Annie, you've been really working a lot on this. And I'm just curious, as you've been developing these abilities, some of these abilities are community ideas. Some of the, we've got a big workshop here. What are some of the abilities that you're most excited about for personal AI?
Oh, I think that one of the most ability that I got really impressed was about I can add some context, so my answers are not plain, so I can add whatever I want, and can give have a kind of a thread through my conversations.
Thank you. Multi-channel communications is key. How do we tie the threads together from all the different communication channels that we maintain relationships on? Cyan, you've been trying to manage this project since the beginning. What are some of the challenges with PMing a AI project like this?
Well, I think the main, the principal one is understanding how everything works or how it should work, because it doesn't work as a regular software development project. I've been working as project manager for the past 5 years on enterprise level projects and startups, and I felt like this was the first time that I was doing project management in a project. Understanding that, well, to me everything sounded magical because everything was like, oh, this prompt do this and this do that and it returns something and it's magic, but it's not like that. So understanding how things work was like the biggest challenge.
Well said. It's not magic. So just to conclude here, what we've really done is we've combined prompt engineering, we've combined personal data. This is actually a style.txt that has some of Annie's tone of voice. So she wanted to feed that in. Hey, try to match this style. And another one of our members pulled down a very cool stylistic sort of structure here that we've been playing with as well. All of this, of course, is something she can combine with her personal data, so her personal AI can then show up in those locations to help her out. So I'll conclude there with just one reminder. We're out here developing applications for personal AI, and personal AI has its place in thinking and feeling. Artificial intelligence is the domain of thinking. Let's leave the domain of feeling up to the humans here. And as we're designing applications, let's try to strike our balance, augmenting our thinking and allowing us to show up better in the world with abilities. Great. Our first panel's coming up. Thank you all. We'll do a break right after this. Panel's an opportunity to ask some questions. So if you do have questions, please hit the mic over there in the corner so we can get your question on the PA and on the recording. Our panelists today, our panel today is going to be moderated by Brittany, and I should probably let our panelists know who's going to be up here. Where's my controller? So the first panel will be our tools panel. We've got Richard Witt will be joining us. Apologies on the mistake there. Balaji Lakshmanan, Pankaj Kedia, and Doc Searles, please, if you'd come up, take a seat. Pankaj, there's a microphone here right behind you for a second mic for you. Brittany, thank you, and yeah, Richard, if you pop up here as well, you're in.
Hello. Hello.
Check.
And Balaji, where's Balaji? Oh, there's
Hold
Balaji.
that. Somebody want to hold
Who am I missing? Doc. Where's Doc? We may have lost Doc. Timing considered. He's got an open chair to come back to.
right. Can everyone hear me? Yeah? All right. Well, we don't have Doc, but that's okay. When he comes in, can we all go, "What's up, Doc?" If I had a carrot. All right, so I'm Brittany. I just want to say thank you, everyone, for being here, and thank you for Kwaai for bringing us all together to talk about personal AI, because it's personal and it applies to everyone, even if you're not in the tech industry. So it's important to talk about this and at a high level where everyone can sort of find their own incentive. So thank you, and thank you, Matt, for doing intros earlier. I appreciate that. And thank you, Richard, for being here and sort of saving the day last minute. We have about 25 minutes. Yeah? Cool. So, hi, Doc. Thank you. Thank you. So, we'll start the conversation. We're over here with about like 10 minutes of questions. We're going to converse here, and then if you want, we're going to have a question and answers. If you want to ask a question or you have something to say, please line up there as soon as it comes to you so that I know how much time to allot to questions, please. All right. So, and we strongly, Kwaai, we love to hear from you. Diversity, everybody's opinion counts in building personal AI, so please stand up and talk to us. So, hello panelists. In speaking to individuals in my own experience outside of the AI and technology space, I've noticed a pattern of indifference towards AI in a personal space, but a strong desire to have control over it in the workplace. So my hope with this panel in a tools focus is to explore the difference between personal AI tools and business AI tools, and whether those tools will be different, whether you think that they are different, and whether the communities that make them will affect the empowerment of individuals. So I'd like to start off with Doc and go down the line. Can you give us one example of an AI tool that you use in your life today, and whether you consider that tool to be personal, business, or both?
I have the mic. Here I am. Well, I mean, it's sort of like asking, you know, do you have a mobile phone in 1986, or, you know, we need the invention that mothers the necessity, you know, where you take one look at it and you say, I have to have that. I wanted to get my wife to text. This is way back a long time ago in the last millennium, I think. And because I went to Europe a lot on business, and she didn't at that time. And everybody texted in Europe, but they weren't doing it in the US yet. And so I gave her this Nokia candy bar phone, which if you twisted it sideways had a keyboard in it. And she texted me one word. It was no. Okay. And then, but she took one, when she was visiting a lawyer doing something in Santa Barbara where we lived at the time, and she saw an iPhone, the very first iPhone. And she said, I can work with that. And she got one. And she's still teaching me how to use an iPhone. Okay. So it's a matter of, there's the invention and now I need it. We don't have that yet. I think if what we saw outlined earlier from our guys here, when that turns into a product anybody can hold in their hand and say, I got to use it, then we'll have it, right? But now we don't. I'll tell you, the personal AI I use right now are just they're the cloud services. They're Perplexity.ai, iAsk.ai. Perplexity is amazing, and it gives you sources, which is handy. And even, it still screws up the sources sometimes. It'll give you a date that isn't real, stuff like that. I liked one of the earlier presenters was showing a piece of like the screen of something, and it had the made-up names in it. Like, I don't know if dall-e is programmed to spell everything wrong or not, but they don't have knowledge. They don't understand. There's not understanding. There's pattern matching, but it's not really intelligence. Intelligence is a human quality. It's not a quantity. IQ is a horrible term. My mother taught in the same school system I was in, and my IQ as a kid had an 80-point range, okay? And by the time I was in the 8th grade, they put me in a slow group, so I go to learn a trade because I sucked at school. But anyway, the thing I probably use most is art. And here's an interesting thing. Have you noticed that AI art already looks like shit? I mean, you can spot it every time. And everybody's using it as a kind of a cheat code. Wow, I could do, here's a farm, here's something else, here's an old car. And they all kind of look the same no matter how much you teach them to make it look original. They don't. It's kind of weird. And I don't think until we get personal AI like we're trying to create here, that we're going to have a breakthrough. So
All right.
that's fine.
So art. Okay, that's awesome.
Yeah, short answer is one word.
Oh, yeah. Boiled it down.
First of all, it's great to be here. Great to see everybody here today. Yeah, a lot of the cloud-based ones are interesting. The art one, I think everybody's seen the example of the old man and the unicorn, right? Have y'all seen that one? It's the old man hugging a unicorn and the unicorn is sticking through his chest. So they got that one off a little bit. So I'll go a little different direction. So from the cloud-based, and some of them are very interesting. Perplexity is pretty cool. I'll go to a small language model, a personal language model approach. There's a company called, a small startup called personal.ai. And this is a model that trains on you. So you have total control over what you're putting into the model, any kind of content that you have, things you've written in particular. It does very well with the written word. And for small like small-time professionals, someone like me who actually do a lot of writing, having all that in one place and then be able to query it and have it massage that, work with it, give you some ideas based on your own context. It links into LLMs when you want it to, but otherwise it really is your own personal AI. Obviously, we're at the early stages of what this could look like, but to me, that's a really cool model, an example of, I'm hoping, where a lot of what we're doing here today will end up.
Cool. So my viewpoint in this is we are still in the AI hype cycle. So first question is what product? It disappeared yesterday. It's something new today. So the real thing that I experienced as I travel last 14 months is that it's helping you ideate a lot of things and makes things faster. So in that sense, I think a couple of things that have stabilized over time, again, they have their differences. You would have noticed too, if you use Anthropic versus ChatGPT. One is more flamboyant, more personal, because guess what? By default, they're taking your data and training it, and Anthropic is not. So those are a couple of tools I use for data that I would personally otherwise put out as a public material. For things that I want to use, there's a great pool of open source material out there. Every one of those products that is available for sale or for a price, you have open source communities giving it to you. So, and the coolest part is all you need is a gaming computer to run all of these. So I would encourage anyone, and including myself, I've been doing nonstop. Every new project that hits, run it locally, try to see what it can do. So that's my approach towards this.
I'll give two examples. How many of you have the Samsung S24 with Galaxy AI?
Wow.
It does real-time language translation. So I call Bill, I speak Hindi, Bill speaks English. If both of us have the same phone, I'll speak in Hindi, he'll hear in English. And you know, English back to Hindi, right? It automatically detects, does it as close to real time as possible. That's personalized AI, right? Second example I would use is my Tesla with autonomous. It's edge AI, inference is happening at the edge in my car. It's personalized to how I'm driving, where I'm driving, you know, what kind of traffic there is, what kind of traffic lights there are. Just imagine if the car did actions based on some average from the cloud. it won't work, right? So I know autonomous is not ubiquitous, but I have an early beta version, and once you take advantage of it, you say you have seen the future. It is very cool. So those are two good examples.
All right, thank you so much, everybody. I appreciate that. So I want to, Balaji, I have a question for you. If so, it sounds like it's in the use case, not so much the tools, where the difference between business and personal comes in. And I'm curious, do you think it matters who builds those tools, and what the differences between them are going to be, or the concerns from a corporate created personal AI versus an open community like Kwaai?
Absolutely. I think it matters who builds it, because what's the motivation, right? Corporate motivation is not same as your personal motivation, so it absolutely matters.
Great, thank you. And Richard, how important are open communities to personal AI that empowers individuals instead of the people that make them?
I think it's a huge difference maker. I come at it as a lawyer, so I think about governance. So, from the technology perspective, you design something to be a certain way, but then once it's sort of out in the world, it is now governed by the laws, the regulations, the rules, the best practices, the policies, all the things that an entity behind it puts in place to run it on our behalf. And if it's an open community that's both done the designing and the governance, you have, I think, the maximum ability for individuals to have their say, to have input into how that application or set of applications or operating system in this case is being operated. If not, then you're taking lots of opportunities off the table for people to have real autonomy and agency when it comes to utilizing those kinds of tools.
All right. So, okay. And Doc, I want to shift to the importance of narrative and story and how that ties into power and autonomy. And how AI affects storytelling specifically. And with tools like Sora that can like generate video or audio and deepfakes very quickly, do you think recent products like that, like, do you think products like that will empower individuals more, or the mass marketing moguls that already have?
What tool is that you're talking?
Like Sora and content creation tools, pretty much.
Yeah. Wow, you can bullshit in so many new ways now. I'm sure. An interesting thing. So Richard comes to things as a lawyer. I come at them basically as a journalist. And the very first job I had at a newspaper, the most common thing said by an assignment editor or a managing editor, these are now antique titles because the papers don't exist anymore for the most part, was, what's a story? Everything has to be a story. And stories are the fundamental format of human interest. We love stories. The problem with stories is that is what you leave out, because if the facts don't fit the story, you don't tell that story. Donald Trump is, let me put it this way. I don't want to go into him, but it's an important point about stories. All stories have three elements. I learned this like on day 2. You have a character, you have a protagonist, that is, you have a conflict or a problem, and you have movement toward a resolution. Those three things. If you don't have those things, you don't have a story. So you can algorithmize that any way you want. But Trump is brilliant because he's a great character. He's a terrific character. He's all character all the time. And he creates conflict on a constant basis. He's brilliant at it. You can automate that shit, frankly, if you want to. And you don't even need the truth in order to make it operate, right? So, and it's a brilliant system that he's got. And I'm amazed no journalists have looked at it and say, look, he's programmatic, it's working, right? So the problem with this, and this is one thing that I'm working on now, in the work I'm doing at Indiana University, is how do we accumulate the facts? Because if you're a decision maker, you need facts. If you're a lawyer, you need facts. If you're a programmer, if you're a business leader, if you're you have any important position, or even if you're an ordinary human being operating in your own house, you need a lot of facts. And to me, that's the thing that an AI really needs most to work with. And that's what we're kind of short on. Turning that into stories is like, that's great if you could do it. It's not that hard. But getting as many of the right facts available to you to make a decision that you need now or soon, or to make sense of your life, is really the big challenge.
Okay, thank you. And Pankaj, last question before we open up for questions from the audience. With your vast experience in venture capital, does empowerment lie purely on the tool itself, or will the VC financial system have to change to support that idea of individual empowerment?
You know, we are in a unique context in that deploying AI is actually very expensive. And so the big tech has seen the winnings with NVIDIA and Google and so on, because we are building the infrastructure. For every dollar of silicon margin, traditionally we have had $20 of application benefit. And I think the application space in different verticals, healthcare and mining and construction and retail and so on and so forth, I think that's where the innovation will come from the startups. Today, the infrastructure innovation is primarily coming from the big guys. So from a VC space, investing in a silicon company like Grok or Cerebras, these guys have raised $1 billion. They're competing with NVIDIA and Qualcomm, who have tens of billions of dollars. It's very challenging. But VCs investing in the application layer or in the middleware layer like security, I think that's where we'll see 100x, 1000x returns. So as long as the VC community is looking at the stack and figuring out what is the right place to target their money, I think we'll be okay.
All right, thank you so much. And do we have any questions from the audience? Are you in line? No, you're just standing. That's cool. You want? Go ahead, Bill.
There's a switch there somewhere.
GPT is a powerful technology invented in 2006 to help people Google translate a very nuanced language, English. So we take this process and we run it over the entire English internet or some part of it. And then we have this huge model of stuff. And prompt engineering is kind of like getting somewhere in this massive tree. So will GPT tell us, will AI tell us it'll destroy us? Of course it will, because somebody talked about that. It depends on how you train it. It's a statistical function. So it's going to change over time, depending on how people prompt it. So my big concern and my question to you guys, it cost $1 billion to build that first model by OpenAI. That's what I heard or read. How is anyone going to validate this large language model and know that it's not completely made up and lying and have other security issues? It's a statistical function. It doesn't think. It can't rationalize stuff. If two things are similar in a curve, it'll show up, and you get what looks like creativity, and people get excited about that. My big concern is the thing I'm throwing out is, how do you validate that? So when people a doctor or an executive is looking at GPT, or someone in personal investments looks at GPT and it's hallucinating. What do you guys think?
Well, as a lawyer, I would say there's some massive liability concerns there. We're all familiar from the early days. Example of the attorney who wrote a brief for, a case and relied on GPT at that time. I think it was 3. Got some stuff wrong. Never bothered to go back and look at the citations and figure it out. So I think so. Just looking at it just strictly from like the point of liability, I've heard someone talk about LLMs a bit like it's almost like it's like the quantum world. Every time you look at it or touch it, you're affecting it and changing it. And the fact that we're in this now situation where we have something called prompt engineering, right? We're trying to figure out how to ask the right questions to get the right answers. Tells me we're a long way from having something that feels stable enough that we can rely on for really important, consequential decisions in society. Will we get there? Most likely. I mean, they're going to get better and better over time, but it's going to take a while. And again, in the meantime, I think the reliance aspect of it is going to be pretty fraught.
I think it's all relative. The first deployments of AI are in customer service, in marketing, etc. I would argue in marketing, hallucination is a feature, not a bug, to borrow your language, right? When I asked ChatGPT to write a poetry, it is hallucinating. I like that. So, or when I asked to create an image, it is hallucinating, right? You don't want ChatGPT or whatever to be doing that when you're talking about autonomous vehicle or healthcare and so on. So over time, we'll get better at it. The upside is so much bigger than the downside. Every time there is a legal mishap, it gets coverage. But all the positive ways people are using it in the legal field, you don't get coverage. But my simple point is, there is a reason healthcare is not mature today, and autonomous vehicles are not left, right, center. We are trying it in marketing, in customer support. We'll move to manufacturing and so on. We'll move to education. Then we'll move to where the cost of a mistake is death. And that's a way off. But like everything else, we'll get better over time. Hi.
I had a question. What is the importance, since we're at an open source conference, and what is the importance of open sourcing of AI tools and or, I guess, models, et cetera, for the ability to eliminate bias? For example, one of the benefits of open source from an information security context is the ability to go and find bugs in the code, right? There's a lot of talk these days in the AI world about hallucination, but there's also bias as well. Does open source, is that the best way to eliminate that?
Right. I can go first. So I think personally, I believe that open sourcing helps people get to experiment with the technology. I think first thing that happened is I think the technology with LLMs and GPT probably got out prematurely before evaluating all aspects of it. So I think second best that can happen is to open source, and that's what they did, right? So now everybody in the peer sector can review, look at it. So I think this kind of eliminates the bias that goes in there, because now you can choose what data you want to put into pre-train. Yes, granted it takes millions, but still people can now take their curated data, which can contribute to that pre-trained model before it gets to fine-tune and all the other stages in its life cycle, right? The second piece is transparency, right? No, by nature, open source, now it's out there for anyone to look at it and review and look out what is in there. And this is not what we are getting from closed source, right? So there's always this missing piece, like what else is going on there? So I think it's very important from that aspect to work with open source aspect of things.
All right.
We are out of time. I'm going to have to call the time clock on this one. Thank you so much to the panelists. Really appreciate you all. We're going to try to abbreviate our break. We've got John Willis coming up next for the next conversation. Godfather of DevOps is in the house here. Take a quick break. Let's make it 5 minutes. It was scheduled for 10. Let's make it 5 minutes. And come on back in here if you need to use the restroom. A good time. We look forward to having you back in here for the second half. Thank you. and get started here. We're only 5 minutes behind our agenda and schedule right now, so appreciate everybody. All right, welcome back in. Find a seat. There are still some seats left if you're stuck on the wall thinking that there isn't. There's a few more here to fill in. We've got 2 tracks for the afternoon, although John was busy all morning teaching us all how to use generative AI in DevOps. So he's really going to punctuate our tools track here. And I'm super, super excited to have John join us today. John was actually very literally my first cloud sales call. And he didn't buy, but really honored to have John here, and thank you, John. Really looking forward to your presentation. Take it away. Good.
I felt bad I didn't buy from you. That was
John, before you start,
okay.
just make sure that this is setting up.
And the AV guys, I get my time back. I get an extra minute now.
Oh, yeah.
All right. Yeah.
Oh, yeah.
Oh man, yeah, baby. Hey, if you do remember, I worked for your competitor. That's right. Evan Studious. Yeah. Yeah. Yeah, it was great. It really went good. It was a workshop, so we were able to. Yeah. So it was good. It was basically a generative AI DevOps workshop, but really very similar. This is like a 20-minute version of the presentation side, and then, but we did it like 2 hours of like labs. And yeah, there you go. It was good. All right, well, good. All right, yeah, anatomy of an LLM. It's all about the data. Stupid. It is the data. You're going to see. I mean, we'll see when we go through this. Like, people will tell you, like, put your data in a vector database, and we're going to talk about that, right? And they'll say, well, read a blog, and it'll say, do it this way, and it'll work perfectly. Then you read another one, and they'll say, do it this way, and it'll work perfectly. And what I found is, like, playing with this for like over a year now, is that the data determines the process. It's not the process. And that's really what the workshop was about, really showing everybody how you could take certain corpuses of data. And it'll apply very well to those last couple of questions, too, about hallucinations. So one of the things, like, if we're going to do this, I might as well try to get you to buy my latest book. But it's about a guy named Dr. Deming. And so my hook is, like, if you want to go do some of these labs and stuff, I have a Hugging Face database with part 1 of my book. So you can actually use that and sort of learn how to take a corpus of data and turn it into something that you can vectorize, which, again, we'll go through all this. So who am I? I've been doing DevOps from day one. I'm not the godfather. I'm the consigliere. Patrick DeBar is the godfather. So, yeah, let's go on. Nobody laughed in my last session. This is awesome. I've done a lot of stuff. Somebody said I've written many books. I've done startups. Most of them are miserable failures, but I got kind of lucky. I sold the company to Docker. I sold the company to Dell, and those were 2 pretty good ones. So I was early in it. Chef. In fact, I was the first person to give a chef presentation at SCaLE. So the first chef presentation at SCaLE I gave. Yeah, that was pretty awesome. I got 2 newsletters. I've got this book called Profound. So if you're interested in that sort of vein, it's about management theory. And so I have a newsletter for that. But I'm actually writing a new book on the history of AI. So the way I've written a book is very much like how Michael Lewis would write a book. So think about how like a Moneyball version of of the history of AI. So it'll be informative, but more, it'll be fun. And so I use my book. So primarily for this presentation, I've been playing with like 4 different corpuses of data and to vectorize, and I'll explain what that means in a little bit. But for this presentation, most of what I've done is use my book. The thing I'll tell you is, these questions about hallucination and sort of bias and all that stuff is one of the ways to sort of counteract that is to create a vector database. And we'll go into that, right? And so vector databases are very important. It's not the only way. There are other ways. But the biggest bang for your buck these days is pick a vector database. And here's the key. Pick a data source that you know really well for your first sort of exercise. Something the data where like you know what the answers are supposed to be. And then there's sort of a stack. Remember when we had the LAMP stack? There's an evolving sort of generative AI stack here. And so you use these stacks and you get to learn your data, what questions am I getting the right answers? And between metrics, between just looking at the answers, you have to remember the first slide said it's all about the data, right? You have to learn. This is not a simple task. A lot of people will say, well, John, I just took my PDF and I put it in Claude and look what it gave me. But if you're having, like if your LLM is going to be a handheld where people are climbing up on telephone poles and changing stuff and the answer will kill them, right? Like loading your PDF into Claude is not the answer, right? So that's the point. If it's a cafeteria, if it's it's your corporation headquarters, where's the best place to go to lunch? Load it into Claude, turn it into an LLM. But if it's high consequence and the answers are you can get sued, create toxicity, or people could die, then you're going to have to work on the data. And that's what this presentation is really about. So this is something we've been trying to play with. The sort of DevOps theme is, and I won't spend too much time on this, and I'd love to geek out. I'll be here the next couple of days. But we're trying to think about, like, what does the stack look like? And this is, I think, since we've worked on this, we've sort of thought of, like, the stack is simple. It's really orchestration, it's vector database, and it's observability, which is evaluations, right? I mean, it's more than that, but, like, that's a good way to think about, like, how we learned the internet was the LAMP stack, right? Well, so think about, like, right now, you could sort of say to yourself, like, these are 3 that I could, if we're really going to get honest with ourselves, we're going to have to do a lot of LLM to LLM, mixture of agents or a mixture of experts. So, like, our answers, this is the ones where, like, if people are climbing up on telephone poles, we want to make sure that the answers are going through an end-to-end continuous process, and we're constantly monitoring the toxicity, the hallucinations, and I agree with somebody, hallucinations are just predictors of what the sort of vectorized data thinks is the best answer. That's it. But hallucinations is actually a terrible name. Anyway, I don't want to spend too much time. I've only got 20 minutes. So when we talk about retrieval, augmentation, generation, RAG, the box that gets most of the oxygen is the vector database. And this is a way to sort of take your data, vectorize it the way maybe it's set up in GPT-4 or in Claude, and this is what minimizes hallucinations. You never completely get rid of hallucinations, but what you can do though is if you're maturing your data in a corpus of data that's vectorized, it's similar to the foundational model, let's say GPT-4, then what's happening is it's actually using your data first to answer the questions. And then if you're sort of constantly running observability tools and evaluations on that, you're making sure those answers are really pretty tight. And you're actually monitoring for when those answers are incorrect and you're quickly addressing them. Right? So, but there are other forms of regs. Like there's a lot of cool ways within LangChain where I can just call APIs, create functions, and sort of embed my information. So the vector database is not the only way. It's just the easiest way to get more mileage than any other way, in my opinion. And so this is a gentleman who I've learned quite a bit, Joseph Enox. He works for a company called EVT, who's local in this area. He wrote this thing early on about how, I don't know if you heard of Perplexity, right? When ChatGPT came out, like it didn't give sources, right? And then Perplexity came out and they gave sources. And they're like, this is great. I don't need Google anymore. This is awesome. But he wrote a blog where he replicated it in like a day and a half. Truth is, right now, in our workshop, we could have replicated in 3 hours. Right? The tools are so easy. And they asked a question about open source. Like open source has been a phenomenal enabler for this world, right? The point here is that yes, it is incredibly easy to get reasonably high efficacy on certain data points. So if the answer is that I just want to put an LLM to answer questions about my favorite candy, or right, like the point is that's a very simple task. In fact, I don't even think you have to go into Python. You could probably just load stuff, a PDF into Claude, or use one of the plugins in OpenAI. But again, if the answers are high consequence, it could create reputational damage to your brand. It could hurt somebody. Then the answer is this is not. You don't take the simple approach. And so if somebody tells you, "Oh, that's simple. Why are you doing all that work?" Depends on the answer and what the consequence of the answer. So the idea behind this RAG process is there's a lot of fiddling, right? Like you get your data in some format. It's either PDF, it's in Markdown, it could be SQL, it could be JSON. It could be any kind of format. And like these orchestrator tools, Llama Index, and I'm going fast, sorry. Probably got about 15 minutes left. Llama Index or LangChain are probably the two most popular in my opinion right now. They all handle this process of loading data. Like they've made it incredibly easy. Like if you look at the LangChain list, there's JQL for Jira, there's SQL, there's like just about any format you get in. Getting the data to render properly is a whole nother. But then you go through this process called embedding, which is really vectorizing your data. Right? What you're doing is like, again, what you want to think about is what foundational model am I going to use as the backing? Like if it's GPT-4, then I want to find out what is GPT-4's suggested embeddings. Then I'll take my data and I'll load that data against those embeddings. And I know there's a lot of jargon here. And then I'll put it in a vector database that looks identical to the GPT-4 vector. Right? And just quickly on a vector. So the idea here is, like, we kind of all know this, right? It's sort of an autocomplete on steroids, right? If I say, I think, therefore, I, right? I'm going to, 99% I'm going to get I am, right? But the way these things actually work is there's sort of pipeline of next word predictors. And then that pipeline gets next sentence predictors. And those sentence predictors get the next paragraph predictors. And that's like incredibly complex math. But the simplicity of it is when you take your data and vectorize it, whether they're doing it when they're training their models or you're creating your own vector, you're literally just putting words, and they call them tokens, in highly dimensional space. So if you think about like a two-dimensional, right? We got X, Y, tells us where it is in chart. Three-dimensional is X, Y, Z. GPT-4 is 1536 dimension. So what that word cat is actually, and you'll see this when you write code. In fact, some of the people who are annoyed in our workshop with, you're going to have to scroll down. It'll show up as 1536 floating point numbers. And that's where it is in this 1500 dimension. And then here's the key. The next word predictor doesn't always have to be, but the default usually is what they call cosine similarity. And what that is the angle. So the closest angle is the next word predictor. And again, it gets way more complicated than that when you start thinking about how it's predicting how to write a whole paragraph for you. But it all fundamentally starts from there. And then it gets crazy with the math. Right? And then, so another thing that you do is when you're taking your data and you're preparing it to get embedded and then vectorized, you do a thing called chunking. And this is where you can read a gazillion blogs about a gazillion ways of the best way to do it stuff. But in the simplest format, there's like these character chunkers where they say, hey, I'm going to take my PDF and I want every 256 characters and don't break up a sentence. Bang. And that might be fine, depending on what kind of answers in your prompts you want to get. A more sophisticated version is what they call the recursive character split. And these are all LangChain examples, but Llama Index has similar ones. And this one's kind of cool because you can get a lot of bang for your buck out of this. Depending on what you want. Because what it will do is it'll make the chunks in whatever size you put. And then playing with the chunk size, you get to know, are the answers better or worse? Like, almost like, in fact, there's some GUIs that I may have time to show you in a demo where I can slide the bar and say, let me try 400. Okay, those answers stink. Let me try 300. Oh, that's a little better, right? And it's all about how the data gets clustered. But what the recursive character splitter does, it has logic in it that won't cut up a sentence, won't cut up a paragraph, it won't cut up a page. But it will try to honor the chunk size. And then the overlap is just in case, like, where we need a little bit of overlap. We don't want to, so it gives us sort of a buffer on both ends. And then there's Markdown. I found Markdown tends to, like, it was kind of interesting. My book was never in Markdown to begin with, but then I put it in Markdown and I got way higher, what they call relevance, correctness, similarity scores, and even the answers were better. So sometimes, but don't think that I'm telling you that's the best way, because it is about the data, stupid, right? It is, but I find a lot of cases if I can get it in Markdown, because what Markdown will do is split on the headers. So if I got header 1, header 2, I'll say I want to split on header 1, header 2, and my book wasn't in this format, but I took chapter, subsection, and by doing that, the chunks were placed in the logical sections automatically by just pulling that out. And then Mary talked about the stack. The stack would be sort of your orchestrator, LangChain, or Longman index. It would be a vector database. MongoDB. I'm a fractional evangelist. How do you like that? I'm a fractional evangelist. I am actually. I made that term up. Fractional evangelist for MongoDB, and so I'm working very closely with their vector database. And I happen to think it is the best, but I'm a little biased, but I'm trying not to be too biased. So you have basically the stack that I'm thinking a lot about is the orchestrators, the vector database, and I'll show you examples of some other vendors other than Mongo. And then there's orchestrators. And this tool I love. It's by a company called Arise. It's fully open source. It's brilliant. And they have a pay for one, but their open source does almost everything the pay for does. And it's just amazing. So the idea is that as I'm putting my stuff in the vector database, these evaluation tools, or orchestration tools, will tell you your relevance, your correctness. It'll tell you if it's hallucinating. It'll actually give you all sorts of data about any drift, even as you're ongoing. So you could set up like a corpus of data, a corpus of questions, and then continually be running these evaluation tools that are always telling you, are you drifting, or is your relevance gone down? So, and they're looking for hallucinations. They're looking for toxicity, bias. So this is your way you monitor. In fact, observability in DevOps is different from observability in generative AI. There's overlap in between latency and stuff like that, but the real key is these things are using LLM-like logic to figure out, are you saying the things that you want it to say? And so what are you looking for in sort of like the full end-to-end? You want to make sure you're eliminating hallucinations to the point you can't eliminate them, but you want to make sure the relevance is in the high. If it's high consequence, you can actually score these from 0 to 100. Right, and you want to make sure it's like 95, 96%. I mean, again, if it's really critical, if somebody was a lawyer on the thing, like if I don't want an answer to like mix up some jurisdictional thing that was already in place. I mean, I can't guarantee these are non-deterministic engines, but if I can basically mature my data to a 96% relevance with 0 hallucinations based on everything I have at this point, I've done my job. And probably the lawyer can correct me, I've done my due diligence, so I've somehow protected myself from liability because I've at least tried to. That's how I've lived my life, right? As long as I have proof. As long as I have proof that I tried to. Relevance, bias, toxicity. Doesn't always work, though. And then there's some things that you need to understand. Again, this is the rocket ship version of all this, but I talked about chunks. You need to understand tokens. Words actually get put in as tokens, not words, so there's a lot, you can read. The dimensionality of the embedding, right? We talked about that, 2-dimension, 5936. Metadata is really important. And not only metadata in the embedding, but metadata outside the embedding. This is another reason why I like MongoDB. MongoDB puts the embeddings in the document objects. So you can have all your sort of metadata in the object as the JSON object, and then have the embedding as just another field. So now I can use the power of slicing through. Give me all the document objects that say, for example, give me all the incidents for Department 5 that happened in the last 3 months, and none of that's actually an LLM question. And then what give me back is all the embeddings in all those documents, and now I can start asking questions like, what was the worst problem? What was that? So that combination of using metadata externally and internally becomes incredibly powerful. And then indexes, every sort of, like any of the tools that you want, like a Pinecone or MongoDB or anyone, you have to create an index which declares the fields and the dimensionality. So, and then like this is a very busy slide, but this is my sort of ongoing list of like all the things you've got to do, to get high efficacy data. That's not a data science term, by the way. But you have to like metadata, like believe in metadata and just be incredibly creative about it. Summaries and chunks. So as you're chunking the data before you vectorize it, like one of the things you can do is if I want to get great answers, so I've got this documentation. I've chunked it up in a certain way, either by markdown or header, but there's something a little bit more that 1 minute, holy crap. All right. Yeah, so the point is I can embed additional information in my chunks before it goes to the vector. In fact, one great example is if the most important answer for this chunk of data, put that answer in the middle of the chunk before you embed it. You can red team, get like as you're sort of launching this thing, don't just give it to everybody day one, just like we do canarying and that kind of dark launch. We would send it out to small groups of people. We'd add more people. We'd add more people. They'd be giving us feedback. We'd be looking for hallucinations. And then so just some of the things, I won't really have time, but some of the demos, this is an interesting thing. So some of the code here, this is all in the workshop. So if you ping me, I can get you sort of the workshop stuff we did. But like trying out different embeddings. And there's actually really good embeddings that are free and cheap that sometimes work phenomenally well. So you don't have to start, even though my labs start off with OpenAI and they right off the bat, because it's the easiest way to get started. But as you learn, you can find out, like there's the one I like is this Beijing Institute, and it's like very low cost. There's in fact no cost, but low cost latency and low cost memory, all that stuff. And in some cases, it gets just as good results as the OpenAI embeddings, right? So play with your embeddings. And you can just start playing, use this embedding, try it, use this embedding. And you can see down here, for a certain question, I'm actually getting similarity scores. So, and I can see sometimes between 1 and 2 embeddings, I can find 10-point difference in the similarity score, the cosine similarity score, right? I've got my book out in Hugging Face, so I've got some labs where you can take those and use that as a corpus of data. This is actually what MongoDB looks like. You can see all your so this is actually a client of mine where I'm building all their product documentation into Vector. So we're creating a chatbot for all their documentation. And the nice thing about Markdown is, I'm going to steal, I'm going over, sorry. If you set up your Markdown right, like especially for product codes, like if I identify like the 3 ticks in the Markdown, it magically gives me code segments. So like now I can ask a question for the Java component of this that does that, can you give me the code, the YAML statement? Bang. I didn't do anything. It's magic. All I had to do is make sure I chunked and said one of the header 1, header 2, the 3 ticks is a code block, So anything that you can think about, and you can make your own. I mean, like you could literally create your own sort of like separate.
much. That was awesome, and the deep dive. Appreciate the abbreviation and the workshops, making those available to everybody.
You're all over it.
All right. Thank you for having me. I want to correct the person who introduced this event. I am actually live. I'm just not in person. And so I appreciate being able to talk to you. I want to talk about AI and trust. Actually, I want to talk about trust. So I trusted a lot today. I trusted my phone to wake me on time. I trusted Uber to arrange a taxi for me and for some driver stranger to get me to my destination. Trusted thousands of other drivers on the road. Trusted people that prepared to serve my lunch. Actually, the entire food supply chain. Any one of them could have poisoned me. Trusted everyone on the Harvard campus where I am. Right? Trust is essential to society. Humans as a species are trusting. I've been watching you in the audience. You're all sitting there, mostly strangers, and nobody has jumped up and attacked the other person. And you kind of laugh, but if we were a room full of chimpanzees, that would be impossible. We trust thousands of times a day. Society can't function without it. And the fact that we don't even think about it is a measure of how well it works. So in this short talk, I'm going to make several arguments. One, that there are two different kinds of trust. There's interpersonal trust and social trust, and that we regularly confuse them. Two, that confusion will increase with artificial intelligence. We're going to make a fundamental category error. We will think of AIs as friends when they're really just services. And three, that the corporations controlling AI will take advantage of our confusion to take advantage of us, right? They will not be trustworthy. Four, that it's the role of government to create trust in society, and therefore it is their role to create an environment for trustworthy AI, and that means regulation. Not regulating AI, but regulating the organizations that control and use AI. Right? So let's back up and take that slow. Right, so trust is a complicated concept. And the word is overloaded with a lot of different meanings. So there's a personal, intimate trust. When I say that I trust a friend, it's less about their actions and more about them as a person. Right? A general reliance, they will behave in a trustworthy manner. I trust their intentions and know that those intentions will inform their actions. So I'm going to call that interpersonal trust. There's also a less personal, less intimate trust. Right? I might not know someone or know their motivations, but I still can trust their behavior. Right? We don't know whether or not someone wants to steal, but maybe we can trust that they won't. So this is more about reliability and predictability. I think of it as social trust, the ability to trust strangers. So interpersonal trust and social trust are both essential to society. And this is basically how it works. We have mechanisms that induce people to behave in a trustworthy manner, both interpersonally and socially. This, in turn, allows others to be trusting, which enables trust in the society, and that's what keeps society functioning. Now, this system isn't perfect. There are always going to be untrustworthy people, but most of us being trustworthy most of the time is good enough. So I wrote about this about a decade ago in a book called Liars and Outliers. And I wrote about 4 systems for enabling trust: our innate morals, concern about our reputation, the laws we live under, and security technologies. And I wrote about how the first 2 are more informal than the last 2, how the last 2 scale better, right? They allow for more complex and larger societies, and they're the ones that enable cooperation among strangers. What I didn't appreciate is how different the first and last 2 were. So morals and reputation are person to person. They're based on human connection, mutual understanding, vulnerability, respect, integrity, generosity, all of these human things. And that's what underpins interpersonal trust. Laws and security technologies are systems of trust that force us to act trustworthy, and they're the basis of a social trust. So taxi driver used to be one of the country's most dangerous professions. And Uber changed that, right? I don't know my Uber driver, but the rules and the technology let us both be confident that neither one of us will cheat or attack each other, right? We're both under constant surveillance and we're competing for star rankings. The critical point here is that social trust scales better. You used to need a personal relationship with a banker to get a loan. Now it's done all algorithmically. You have a lot more options to choose from. But that scale is vital, right? In today's society, we regularly trust, or not, governments, corporations, brands, organizations, groups. Like, it's not so much I trusted a particular pilot the last time I flew somewhere, but instead I trusted Delta Airlines to put well-trained and well-rested pilots in cockpits on schedule, right? I don't trust the cooks and the waitstaff at the restaurant, really the system of the health codes they work under. Like, and I couldn't even describe the banking system that I trusted when I used an ATM machine this morning. Right? Again, this confidence is no more than reliability and predictability. Right? To think of that restaurant again. Imagine it's a fast food restaurant. It employs teenagers. Right? The food is almost certainly safe. It's probably safer than in high-end restaurants because the corporate systems of reliability and predictability guide those people's every behavior. And that's the difference, right? You're going to ask a friend to deliver a package across town, or you can pay the post office to do the same thing. The former is based on interpersonal trust, right? Based on morals and reputation. I know my friend and how reliable they are. The second is a service made possible by social trust. And to the extent that it is reliable and predictable, it's primarily based on laws and technologies. Both of those will get my package delivered, but only the second can become the global package delivery systems, that is FedEx. And because of how large and complex society has become, we have replaced many of the rituals and behaviors of interpersonal trust with the security mechanisms that enforce reliability and predictability, social trust. But because we use the same word for both, we regularly confuse them. And when we do that, we're making a category error. And we do it all the time with governments, with organizations, and with corporations. We might think of them as friends when they're actually services. And both language and the laws make this an easy category error to make. Right? We imagine they're friends, but they're not. Corporations are not capable of having that kind of relationship. And we are about to make that same category with AI. We're going to think of them as friends when they're not. So a lot has been written about AI's existential risk. Right? The worry is they will have a goal and will harm humans in the process of achieving it. You probably read about the paperclip maximizer. Kind of a weird fear. Science fiction author Ted Chiang writes about it. Like, instead of solving all humanity's problems or wandering off proving mathematical theorems, the AI single-mindedly pursues the goal of maximizing production. And Chiang points out this is every corporation's business plan, and that our fears of AI are basically fears of capitalism. Science fiction writer Charlie Stross takes it one step further. He calls corporations slow AI, by profit maximizing the machines. And near-term AI will largely be controlled by corporations, which will use them towards that profit maximizing goal. They won't be our friends. At best, they'll be useful services. More likely, they'll spy on us and try to manipulate us. This is nothing new. Surveillance is the business model of the internet. Manipulation is the other business model of the internet. And we use all of these services as if there are agents working on our behalf, when in fact they are double agents also secretly working for the corporate owners. We trust them, but they're not trustworthy. They're not our friends, they're services. And it's going to be no different with AI. But the results will be much worse for two reasons. So the first is that these AI systems will be more relational. We'll be conversing with them using natural language. And as such, we will naturally ascribe human-like characteristics to them. And this relational nature will make it easier for those double agents to do their work. Right? So did your chatbot recommend a particular airline or hotel because it's truly the best deal, given your particular set of needs, or because the AI company got a kickback from those providers? When you asked it to explain a political issue, did it bias that explanation towards the company's position or towards the position of whoever political party gave it the most money? The conversational interface will help hide their agenda. The second reason to be concerned is that these AIs will be more intimate. One of the promises of generative AI is a personal digital assistant. It's what we're talking about here, right? Acting as an advocate for you, as a butler for you, as your agent to others. And this will require an intimacy greater than your search engine, than your email provider, your cloud storage system, your phone. You're going to want it with you 24/7, constantly training on everything you do. You'll want it to know everything about you so it can most effectively work on your behalf. And, taken to its extreme, it'll help you in many ways. It can notice your moods and know what to suggest, can anticipate your needs and work to satisfy them. It'll be your therapist, your life coach, your relationship counselor. You will default to thinking of it as a friend. You will speak to it in natural language. It will respond in kind. If it's a robot, it'll look humanoid or at least like an animal. It will interact with the whole of your existence just like another person would. And the natural language interface is critical here. We are primed to think of others who speak our language as people. And we have sometimes having trouble thinking of others who speak a different language that way. Right? We make that category error with obvious non-people, like cartoon characters. We will naturally have a theory of mind about any AI we talk with. Or more specifically, we tend to assume that something's implementation is the same as its interface. And that is, we assume that things are the same on the inside as they are on the surface. Like, so humans are like that. We're people through and through. A government is systematic and bureaucratic on the inside. You're not going to mistake it for the person when you interact with it. But this is a category error we make in corporations. We sometimes mistake the organization for its spokesperson. Now, AI has a fully relational interface. It talks like a person, but it has an equally fully systemic implementation, right? Like a corporation, much more so. There are no people in there. The implementation and interface are much more divergent of anything we've ever encountered to date by a lot. And you will want to trust it. It'll use your mannerisms and your cultural references. It'll have a convincing voice, a confident tone, or authoritarian manner. Its personality will be optimized to exactly what you like and what you respond to. It will act trustworthy, but it will not be trustworthy. We won't know how they're trained. We won't know their secret instructions. We will know their biases, either accidental or deliberate. We do know that they are built at enormous expense, mostly in secret, by profit-maximizing corporations for their own benefit. And I think it's no accident these corporate AIs have a human-like interface. There's nothing inevitable about that. It's a design choice. It can be designed to be less personal, less human-like, more obviously a service, like a search engine. Right? When ChatGPT types out its answer, that's bullshit, making you think something is in there typing. And the companies want you to make the friend service category error, and they will exploit you mistaking it for a friend. And you might not have any choice but to use it. Because there's something else we want to talk about here when it comes to trust. and that's power. Sometimes we have no choice but to trust someone or something because they are powerful, right? We're forced to trust the local police. We're forced to trust some corporations because there are no viable alternatives. Or to be more precise, we have no choice but to entrust ourselves to them. We will be in the same position with AI. We will have no choice but to entrust ourselves to the decision making. And the friend service confusion will help mask this power differential. Right? We'll forget how powerful the corporation behind the AI is because we'll be fixated on the person we think the AI is. Okay, this is a long-winded way of saying that we need trustworthy AI. AI whose behavior is understood, whose training is understood, whose biases are understood, whose goals are understood. And the market will not provide this on its own. Right? Corporations are profit maximizers. And I think the incentives of surveillance capitalism are just too much to resist. It is in the end government who provides the underlying mechanisms for social trust essential to society. Think about contract law or property law or personal safety law or any of the health and safety codes that let you board a plane, eat at a restaurant, or buy a pharmaceutical. The more that you can trust that your societal interactions are reliable and predictable, the more you can ignore the details. And government can do this with AI. I mean, I want AI transparency laws, when it's used, how it's used, what biases it has. I want laws regulating AI and robotic safety, when it's permitted to affect the world. I want laws that enforce the trustworthiness of AI, which means the ability to recognize when those laws are being broken and penalties sufficiently large to incent trustworthy behavior. I think a lot of countries are contemplating AI safety and security laws. EU is almost there, but I think largely they're making a mistake. They try to regulate the AI and not the humans behind them. AIs are not people. They don't have agency. They're built by and trained by people, mostly corporations. Right? And I want AI regulations to create restrictions on those people and those corporations. And we need one final thing, public AI models. I want fundamental models built by academia or nonprofit groups or government itself that can be owned and run by individuals. And in the last question session, this came up. Term public model is thrown around a lot. I want to detail what I mean. It's not a corporate model that the public is free to use. It's not a corporate model the government is licensed. It's not even an open source model. It's a public model built by the public for the public, with political accountability, not just market accountability, openness and transparency paired with a response to the public demands, available to anyone to build on top of, means universal access, and like a foundation for a free market in AI innovations. And then this would be a counterbalance to corporate-owned AI. So I don't think we can ever make AI into our friends, but we can make it into trustworthy services, right? Agents and not double agents. But only if government mandates it. We can put limits on surveillance capitalism, but only if government mandates it. And I think it's well within government's power to do this. And more importantly, it is essential for government to do this. Because the point of government is to create social trust. To the extent the government does this, it succeeds. And to the extent the government doesn't do this, it fails. And I know this is going to be hard. Today's governments have a lot of trouble effectively regulating slow AI, corporations. Like, why should we expect them to be able to regulate fast AI? But they have to. We need government to constrain the behavior of corporations and the AIs they build, deploy, and control. Government needs to enforce both predictability and reliability. And that is how we can create the social trust that society needs to thrive in this AI age. So thank you.
Thank you, Bruce. That's awesome. Didn't get the mute off in time so you could hear all the applause in the room. Thank you. There we go. Now the mute's off. Really appreciate you coming in and sharing that with us, Bruce. Thank you so much. Next up, we have
on my little window, so take it away.
All right, thank you. Great. So we're coming up next. Can we get this one back? Awesome. Next up is Ruth Rasul. She's going to be talking to us a bit more about AI and education. Remix edition. Nice. Yeah. Thank you, Joey. So Ruth is a Kwaai advisor and board member. She's also an educator, 16 years at College of the Canyons in Santa Clarita here. Going to be talking about this trust element in schools between students, teachers, and ChatGPT. There's a lot of questions about how our education system is going to cope with this. So we're very happy to have Ruth up here. You plug right in, are we? And do you have audio?
There will be audio, yeah. So we need the box.
And then here you go, Ruth. You're on the mic's on here.
I know that my son is going to come and change the screen in a minute.
You can take the mic off if you want and walk around.
No, I'll stay here.
Loaded up.
That cable's seen better days, hasn't it?
Yeah, there we go.
Let's slide.
Top. Let's go from here. And you're up.
Okay, and when it comes to it, you're going to...
Oh, it crashed. That's Microsoft for you. You can take the mic and walk around, it'll be better, because you're not going to be able to see.
That's fine. You're going to put the questions in when it comes to it?
Yeah.
And load, how are we going to load up?
It's over there. Take it away.
Okay, but we're going to be able to load up Miss Penny or whatever.
Not concurrently with these screens. But
well, it needs to be when we get to the last one.
Okay.
And then you're going to put the questions in?
I'd take the mic, yeah.
Okay. Okay, I think we're ready. So, until we were transported to Harvard, we hadn't really talked too much about education, but that's what I'm going to be doing. This is me. I teach at College of the Canyons. It's not quite...
I think you need to keep doing it, take it and walk around. So
the reason I don't like to hold the mic is because I wave my hands around. I'm not Italian, but... yeah, so I teach at College of the Canyons. I teach English. I've been doing that for some time. And you'll all remember in this room that ChatGPT 3 came out in November 2022. It was in my classroom in December 2022. Not from me, from my students. And they were writing some really good essays, or so it looked. So I didn't know what ChatGPT was because my husband's mealtime conversation hadn't got to that. But it looked like plagiarism because I got two very similar essays from two students who were working together. So that brought up all this, these issues about is using AI cheating? Can you use it with integrity? Can you monitor the use of AI in the same way that you use plagiarism tools? So on campus, I got involved in various constituent groups on campus that are concerned about using resources with integrity. We have to be concerned about students' safety when we're exposing them to all these things. I used to use turnitin.com. I don't know if you know about that, but it's a plagiarism checker, it tells itself. Students don't really need a plagiarism checker because they know when they've plagiarized. They don't need somebody to tell them that it's 80%. And now turnitin.com has an AI component to it as well. So we were concerned about academic integrity for both faculty and for students, that we're teaching them how to work with integrity. That's the major goal. We're worried about academic freedom, and we're worried about the compliance that we have to have with Title V and all those kinds of things. So I got involved in all these groups on campus. And a lot of my colleagues are, how I think I put it politely here, reluctant to engage with AI. And they are, some of them are retiring because they just don't want to deal with this anymore. So this is not education. They spend so much time finding ways to catch students using AI, which I think is a fool's errand. I mean, you will never catch it all. And then what do you do once you've done that? Do you report them to student conduct and so on? So I've been looking for ways in the last year or so. I've been looking for ways to incorporate it into my work, and finding ways for it to make my job easier. These are examples of the kind of communication I get from my students. For the most part, post-COVID, can we say post-COVID yet? I don't know. But recently I've been teaching online. So those reluctant colleagues will say, oh, it's so much easier to cheat online. It's easy to cheat if you're sitting in the same room. People didn't start cheating because of ChatGPT, we know that, right? These are some of the emails I get from people. And I didn't copy and paste because I am concerned about my students' privacy, but this is very close to what I actually get. 10:40 p.m. Hi, Prof. I thought there was something due today, but I can't find it. I've looked everywhere. I'm sure they haven't looked everywhere. Can you get right back to me so I don't have to lose points for late work? Thanks, have a good evening. 10:40. Now this is partially a factor of teaching online. And you have to discipline yourself to say, no, I'm going to stop looking at emails. I haven't perfected that yet. Because I also read this one quite close to the time it was sent. 4:15 a.m. Dear Professor Rasul, this sounds nice. I completed the day one assignment roll call and syllabus, and I responded to another student who did a really good job. Discussion boards are not a good thing. Pedagogically, they're not a good thing. But what people do, when you tell them they have to respond to somebody, they say, you did a really good job. So that's kind. I'm waiting to get my textbook. Amazon says it's on its way. Is there anything more I should be doing this week? These are very typical kinds of emails I get. And my job is to not respond to them too quickly because the response would be not with academic integrity. We're going to that last question. The last question was really good. The last question was, I think it was something like, oh, yes, it was, Dear Ruth, some of them do that. I looked at the essay prompt, and it was a semiotic analysis of consumerism. Can I write about dialectical materialism? It's kind of close, but not close enough. So I was looking for ways to make that part of my job more simple. So I said to my good friend Balaji, could you take the data that I have? I use this, my institution uses this education platform called Canvas. Good, you're nodding. Blackboard, same kind of thing. Where, again, we have a privacy issue because I'm saying to students, upload all your data, all your assignments, your essays, everything. Put it all in Canvas and I'll grade it there. I have currently 60 classes on Canvas over the years, and a lot of it is repeated. So I'd like to be able to take my syllabi and just update them and then move it on to the next course. Let's do, so I asked my assistant here a series of questions. Can I use ChatGPT? You need to type. What
kind of type are you?
Okay.
Can I use ChatGPT?
Yes, you can use ChatGPT as a tool for assistance in your course, British Literature Roman 2 at College of Canyons. However, it's important to remember that while ChatGPT can provide helpful information and insights, it should not replace your own critical thinking and analysis. As Ruth Russell mentioned in the syllabus, the goal is to adapt these new learning tools to enhance our ability to analyze, think critically, and form our own opinions. So, while ChatGPT can be a valuable resource, it's essential to use it wisely and not rely solely on its generated responses.
Now, you can see there are 3 citations there, and that will take you to the point in my syllabus. It will take you to a point in the video lecture where I've mentioned it. So that's all pretty accurate. What this is telling me, though, is that I need to refine my language in my syllabus, because I would much rather she didn't say, yes, you can, if, and the rest of the explanation. I'd rather she said no, unless you do these other things. So that's just, you know, a rhetorical situation that I'm in.
Can I ask her the last question?
Ask her.
I'll ask the last question.
Okay, so this data is taken from a British literature class. It's British Literature 2. One of the questions I asked it was, can I write about Shakespeare? It said, yes, you can, because what I realized was that unpublished stuff in Canvas is still accessible to this data. So it said, yes, you can. And I said, no, you can't, you can't. And then the rest of it was about modernism and Virginia Woolf. And so Reza asked this question.
I'm going to have to wait till you stop because I'm talking.
Go on.
Who's afraid of Virginia Woolf? Who's afraid of Virginia Woolf?
Who's Afraid of Virginia Woolf is a play written by Edward Albee. It premiered on Broadway in 1962 and went on to win multiple awards, including the Pulitzer Prize for Drama and the Tony Award for Best Play. The play explores the complex relationship between a married couple, Martha and George, as they engage in a late-night conversation and games with a younger couple, Nick and Honey. The title refers to the character Virginia Woolf, a prominent British author, and her impact on the characters' lives and relationships.
Okay, so that's very different to when you tried it before.
It's not British literature. I hope you all know that, right? But because the other questions were about Virginia Woolf, then she said, I think you're getting confused because you're asking me about Virginia Woolf. That's a play, she told him, not part of the syllabus. So you've got to be careful about, as always, good data going in, then you get a reasonable output. And you've got to be careful what you think is unpublished that it can still access. So it's going to help us refine the language of our material, our course content.
Okay.
There you go.
Thank you very much. Back to Matt.
Thank you, Ruth. Appreciate that. The variability of the bot's performance here, as we've been talking about, I think John can help us refine that thing as well. Wonderful. We got another panel coming up. We're going to do this panel, and then we're going to take another quick break. We're running a little bit behind schedule, but we'll make that up towards the end. We've got some great content coming up at the tail end. Kai Pham is going to be doing the fundamentals keynote about fundamental AI research and science in the area, talking a lot about causal network reasoning being biologically inspired. Without further ado, I want to invite Brittany back up to the podium here, as well as our panelists, Sushil Kumar, Mark Vega, Ruth, you're not done yet, and Sam Johnston. If you could grab a chair.
Hello, hello. It's on. Okay.
Check.
Who wants it? We got two. Okay, great. Yeah.
If you'd like to ask a question, maybe not at this volume, but talk gently over here.
Come on, just get in line now. You know that's how it works. Come on. Ruth's dying to answer some questions. Come on.
All right. Set my timer. Okay. So we just finished the tools track, and we've heard wonderful things from Ruth and Bruce about policy, and now I want to continue the theme that we started in the tools panel about the difference between work-related policy and personal AI policy and what the difference is there. That's really what I want to focus on in our time here. And again, thank you, Matt, for the intros. Hi, panelists. Welcome. Thank you for being here. I want to start the conversation. Sorry, guys. So the policy conversation is going to continue, and I want to continue the idea, the theme of like personal versus business AI policies, where our focus is currently and where it might need to shift. So I'd like to go down the line and ask you all, can you give us one quick idea of what you personally are focusing on or watching in AI policy right now, and whether you consider that focus to be personal, business, or both? And I'll start with Ruth.
Well, I think, as I just confessed, that my personal time bleeds into my professional thing, so I'm answering emails at 2 a.m. So I'm trying to reestablish that barrier between my personal use and using it rather to perfect my communication with students, so that it would be nice to be able to have that assistant to say, if you're trying to get an answer after some cutoff, some reasonable time, then ask the personal assistant. Don't ask the professor, because the professor is tired and needs some rest.
Hey all, thanks for being here this afternoon. I love that you're here. No, really, I love that you're still here. Here's why. Come on, wait a minute. These are, first of all, these good people, they're just developers, right? DevOps, DevSecOps. Come on, who many DevSecOps people, not just DevOps? Okay, a couple of hands, come on, thank God. I'm the second guy who identified today as a lawyer. Okay, so great question, Brittany. The question or the response to me really is that we've never had a time like this. And everybody they talk to ask what AI tools they're using. Let those real people, right? Like you're the special ones. You're the DevOps. You got to get everybody to use every AI tool you can. Tell them don't be afraid of it. Tell them to jump on board. And I agree. Who was it? Somebody said hallucinations. It might not be the right term because you're right. It's an asset. It's a tool. It's no bug. But as a lawyer who jumped on 3 and 3.5 and now 4, 4.5, I can't get enough of my lawyers to start using it. They're all afraid and they're old school. They're sitting on old school ivory towers saying that's not the way it's supposed to be. There are the teachers who are leaving in droves. My God, people, don't let them do that. Brittany, I'm not trying to hijack your question. I love you for the question. Yeah. I'm going to pass this on to the next person, but I'm glad you're here. I'll beg you, ask some questions to this panel. I mean, you got them here at this point, and we're glad you're here.
Yeah, thanks, Mark. So I think I can shed some light on what we are doing at Kwaai in terms of our focus on the policies with respect to whether on the corporate AI or on the personal AI. So as you would have heard right at the beginning, these PII tools that we are making, the open source PII system, the operating system that we are making, so it essentially needs a contract with your personal AI that can effectively integrate to the corporate AI, your employers in most cases. So I think that's the focus for us right now. And what we are trying to do is evolve that framework, how both the tools can coexist, because right now there is nothing that the employee gets from any of the AI that employers use. So all the work, all the skills, everything that is being done at the workplace does not benefit the employee in any manner. And the whole intent of this personal AI is that when we go with our own tools and when we have these policies in place, then that will help the employees get some benefit from what they have contributed to the organization. There would be clear rules, clear transparent direction in which both agents will be able to interact, both on the employer side and on the employee side. So I think that's the key focus for us for now. Corporate, yes, there are things which are going on, but our focus is on the personal AI. Over to Sam.
And if I pick up on the tools line there, I mean we've been using tools for a very long time, whether it's hammers and screwdrivers and so on. I think AI is similar. And if you think about it like kind of transhumanism and being able to extend your capability, it means that you can either do more work in the same or less time, or as an employee you can hire less people, right? But where it starts to get difficult, and I think for a lot of us our work does blend into our play. If you do what you love, you never work a day in your life. But if you're starting to bring, I think lawyers and coders and so on are quite creative, right? We're writing code and we have
lawyers and coders are quite creative. Yes.
And maybe that's a bit contentious, but we bring our knowledge, our algorithms, our snippets and so on, and we naturally use them. We store them up here and we use them as part of our work. But to the extent the company can start to take over that, right? If your TA starts to answer the questions well enough, well, it's like, why do I need the teacher, right? So, and that's where one of the really fundamental questions here that we need to kind of address is, where's that line? When you work for a company, typically you work for hours, you're paid by the hour, and your output is owned by that company, right? And you wouldn't begrudge a company for training an AI like a copilot, a coding copilot, on the company's own code base. Right, but where does that kind of, and it's going to be necessarily messy, right? It's not going to be black and white, it's going to be quite gray.
Great, thank you everybody. That was great input, I appreciate that. Mark, I'm actually going to skip to you, because I think, Sushil, you actually answered my next question. I love that you're focusing on personal AI, that's where it should be. Good job. Mark, my question for you is, should AI regulation concern itself on the data security level or the user experience level? Is one more important or vital to privacy or security of the individual than the other?
That's a great question, thank you. We need both of those pieces for real, for sure, right? I heard about Kwaai, I don't know, a little while ago, a couple of months ago maybe, and I'm really glad I heard about it because have you watching and been listening earlier today? We have an opportunity to let people understand that maybe for the first time ever, they can get back in control of their data. The first guy that came up it wasn't Willis, but was it Doc Searles? Well, first of all, does he have a church? I want to join the Doc Searles. What? Are you kidding? He put up the slides, all those privacy. Oh, you feel like when you go through the privacy policy, selections, the corporations are interested in having you believe that you're being protected, that you can be safeguarded now. Just say, I only want the essential cookies. Well, there's still cookies. There's still cookies. My mom used to say that, Mark, there's still cookies. So we can't succeed to move forward without an understanding that what matters is consumers and users UX. It has to be familiar and comfortable for me. There's a little Henry in the background. I see him right there, right? It's got to be good for Henry, man. It's got to be good for all of us. But at the same time, switching the other handle, there's Doc. Now look at that. He showed up right in at the perfect time. We're going to join your church. I'm going to lead the charge because without you keep talking about it, where would we be? So we got to hold the corporations accountable. So we need our UX to be good because the consumers need it. But without not just DevOps, but without DevSecOps, we're going to be in a little world of hurt. But we can't let the consumers be scared about this, but we got to really be with open eyes, recommend everybody out there that this is real. You can capture your privacy. How you do it is specific, but not doing it is a disaster. Does that help? Does that answer the question a little bit? Okay, thank you.
Thank you so much, Mark.
Thank you.
And Ruth, as an educator, do you feel educational policies is personal-based or business-based? And does it depend on the actor?
Okay, I wasn't looking forward to this question because some of my bosses might be listening. I'm thinking of Doc's pyramid with the psychopaths at the top, and I'm somewhere. I think the students are at the bottom, and I'm somewhere in the middle. Were they sociopaths? Oh, some kind of.
I think those are your boss.
Oh yeah. Some crazy people at the top, who have different objectives to the people that are actually in the classrooms doing the teaching. We're concerned with equity, we're concerned with DEI, we're concerned with not just teaching them the facts and figures that's on our curriculum, but sending them off to be productive people in society. And many educational institutions now are run on a corporate model, that the students are customers, and that's not working so well, I don't see.
Okay. Sam, as an engineer, how realistic is it in implementing regulation in the programs themselves, in these AI tools themselves? Is it realistic, even if we manage to come to an agreement on certain regulations, how we can implement them?
Yeah, so look, I think for the first thing is, for the first time ever, we can actually build a lot of this stuff, right? So we can actually build on top of a foundational model that knows how to speak English, or maybe it knows how to speak accounting with the GAP principles, or maybe it knows how to speak legal, trademark law, for example. And then you can build on top of that. Now, you do have to be a bit careful that stuff like the Virginia Woolf quote doesn't end up in your foundational model or pop out of your previous courses. But to kind of segue into that specific question about being able to implement regulations, right? The problem there was kind of an access control failure, it was a security failure. And in a past life prior to, I used to work for Google, but before that I worked around Google, and we had a thing called the Google Search Appliance, which doesn't exist anymore. And what it would do, and this relates to what John alluded to before about the RAG, the retrieval, augmentation, and then generation. You can take these models, you can fine tune them, which is a lot of hard work, and it doesn't necessarily work very well. But what you can also do is you can augment, you can kind of add, you can mix in the results of a database query. And the database could be your email, or it could be a PDF, or it could be a whole bunch of different sources that you're pulling the data in. And if you don't have the security clearance to access those documents, or if you did have them but then you lost it, right, then you just don't mix it in when you generate the response, and then that thing is not visible anymore. And that can be done in real time, and you kind of, at the time you could see the results pop up as it determined whether or not you had access. So yes, not only does the technology now for the first time enable us to build these tools, like the personal AI, the Pi system, but it actually allows you to enforce security at a very, very granular level.
That's really exciting. Mark, did you have something?
No.
All right, fine. So I have one more question for Sushil, and then we have about 5 minutes for audience questions. I forgot to mention that the microphone for questions is over there. Please participate. We want to hear what you have to say. That's what the Kwaai community is all about. It's not about the 5 of us up here. It's about everyone in the room. So we'd love to hear what you have to say if you have any questions. But Sushil, it's really exciting that we have the tools to implement policy these days. But it doesn't really, I'm curious what are some of the challenges facing policymakers today with like the complexities of AI, like in the communication layer and the technology layer, and are you, what's your experience with that?
I think it's a great question, and I'll probably pick up from what Pankaj mentioned in his keynote. And I think the 2 key takeaways are, one, the pace at which the technology is advancing. So the steep curve, even after like 70 years, it has been there, but now that with the chat GPT and everything that we have seen. So that's one part, the pace at which the technology evolves. And second is the global scale at which it does. So it's not like confined to a particular set of global location. It's all over the world. So that's the big challenge. So rather than the technology or any complexity of just the system itself, it's more about how it is happening. So the pace and the location. And for those two, how do you regulate the policies? Because even, and I'm talking of the developing countries like India, so the policies evolution is very slow. The people are just not educated. And we have some of our members that work on our working groups on the policy track. So from Europe, so even over there, like developed countries, the structured democratic dialogue process that they follow, even that is like, very difficult to engage people to come to that level of, level setting and having those regulatory policies in place. So I guess those are the big challenges that we need to see. And in terms of solution, so a couple of solutions, I think. One is definitely the education and outreach, which is what at Kwaai, we are, passionate about. That's what we are trying to do. Engage more and more people, get the education, dissemination, and make sure that in those ways that people understand that they use the AI tools, and that's where the personal AI also comes in. So I think outreach, education is one part, and then on behalf of the governments and even like academia and other, say the non-profit organizations, it's more about like rallying together, engaging with different stakeholders so that regulatory framework can really be evolved. Because corporate AI we've talked about, personal AI definitely the most important part for us. So I guess if we look at that overall frame in which we need to operate, so those complexities is what we need to look at. I think that's the view that I would have on this one. Thank you.
Great, thank you so much. All right, so any questions from the audience? All right, we got some. There we go.
Oh, it's working.
Oh boy.
Good, good. First, before I go to my question, I really want to thank Reza and Matt and everybody on the team. How impressed I am with how much progress they've made since my first exposure last year at DataCon. Really, it's impressive, and I wish you the best, really. And I really congratulate all the entire team for doing this and taking the lead on the side of the people, as opposed to the corporate world.
Thank you.
And I'm impressed also that we have some attorneys that they're supporting us as well. Now, as somebody that has been around much longer, both in academic and industry, I just want to remind you that internet initially, as we know, started in academic world, and as long as it was only text-based, the progress was gradual. But once Linus came up with the web, all of a sudden it opened up the floodgate. And I know that some of you know that the porn industry was the first industry that jumped on it as soon as the images and video was added. I'm just reminding you of that because now that I see the future with AR, MR, VR put together with AI, probably the same dark industries are rushing to the banks to come up or to funders to come up with the money to try to exploit this. So we've got to watch for that, and what are we going to do so that it will not become a much more serious problem? That's one thing. And the second question that I have is on the issue of security, privacy, and ownership of the data. Because right now, even with all the good intention that I see, if we develop all of that, it looks like the data becomes a lot more granulated and a lot more specific to individuals. And there will be a single source of truth. What happens if there is a breach and people from the dark side get access to those data, and what they're going to do with this and how we could safeguard it? Thank you again.
Thank
you. So that's my question, and if you could address.
Thank you for that question. If I may, how about this? And this, I'm not turning it against you. I'm saying thank you for that. I'm going to ask every one of you guys, if you haven't joined and become a member of Kwaai, please today do it. Here's why. This gentleman's been here the whole time, right? He's been here for decades, and he's been here today. We've all been here a long time. And you were right about the porn. There's no doubt that early industries, all kinds of industries making money, move quickly. Here's why I would ask you to join today. Your individual comments and participation on the various Kwaai channels and the Kwaai Days on Friday, it's simple to connect with a lot of people who are interested in articulating your own concern. And so the reason I don't have an opinion about my opinion is only one opinion. It doesn't matter much, but my opinion does matter. Right now, with a microphone in my hand, I'm just asking you to come and do this. It's really amazing. And I'm not going to repeat an old story that Reza heard 20 years ago, because when I started out, there was a porn star named Mark Vega. And if you Googled lawyer Mark Vega, and like it showed up. But now time's passed and nobody's going to Google that anymore. Thank you. This is a private room now. Anyway, this guy, next guy, let's hear it. Let's give us another question.
Well, actually, we're a little bit behind schedule. And
no, let's get a few more. We're going to compress our break. Sorry, we'll offer a quick one. We do want to get to some more questions from the audience. We also have an opportunity for member voices at the end. To give some long stories and some context. So if you can keep them quick to some questions, that'd be great.
And it's incredibly cool. I'm very excited to watch this, and it aligns so much with my ideals. I have a question for Ruth, which is, literature is very important to me. I always love seeing the intersection with tech. And in your presentation, one of the student examples you showed, the one at 4 in the morning, saying, hey, I read through the syllabus, am I waiting for my book, is there anything else I need to do? To me, that just spoke of such massive anxiety. Yes. And it's a very unhealthy being up at 4 in the morning, trying to hyper-optimize that. How do you see this changing your relationship with the students? And
that's an excellent question.
And do you see this as something that would also support the more less academic but more mentoring aspects of teaching, and how do you see that relationship changing over time?
It is an opportunity to reach students where they are, not where they're at, where they are.
So yes, you do recognize that after a few years doing this, you do recognize that when a class starts, there's always somebody who says, "Oh, I've got a question." Oh, and you answer that question, and just one more question, and then they overthink and they have so much self-doubt and anxiety that when they actually hand in the assignment, it's just fine. I'm dealing with one right now who will email me 6 times a day, and the work is fine. But you have to learn how to navigate that, and I think having these extra tools will make it easier to do that. Because if you're just in the classroom and you've got no tech, then you miss so many opportunities to connect with those people.
Great question, thank you. All right, who's next?
Hi,
Adrian. All right. This is for all of you, really. Thank you, Kevin. I mean, Adrian. Adrian. The Fourth Amendment comes into play here, ladies and gentlemen. Let's not forget about that, right? Government agencies and the government. Illegal search and seizures. We have the right to be protected safely so that our goods and our information, our data isn't freely given. So be mindful as we develop personal AIs. Again, come and join us. We need your voices in this. Is critically important. So I'm conflicted to love lawyers more or cops more, but only because there's 1,000 other categories of people that I love too. So, but I wanted to say Fourth Amendment, don't forget it. Our privacy is mission critical. If we create an AI and we have the authority and we think we're going to give all of my own information to my own personal assistant, am I going to tell it everything? Like, I need to be able to delete it. Delete some of that stuff. Just like a cool resume, I want my personal AI to be customizable. I want to be able to make sure I'm giving the information I want to give out. So I'm asking your brother who's going to go be a lawyer for a while before you decide to be a cop. How's that for an answer? That's what I'm going to ask you. Get this away from me.
Yeah, I'll be quick. I have a question for Ruth and Mark, but I believe your answer may affect all of us. So what you showed us today, in that scenario, suppose with this AI tool, if you can also have your voice along with everything else, will it be possible for you to be doing multiple lecturing at multiple places or multiple locations and multiple universities? 1 second, because the reason I asked that, last November, I had an incident where a person was doing multiple jobs using AI, and we couldn't catch him. The only reason it happened in Navy, we caught him because in DoD, where all of us get issued a CAC card. And when we went, well, after 3 months in the job or 2 months in the job, we went for validation of the CAC, or getting a CAC. We discovered that he already had one and working in another department of the Navy. So now there's no such thing happening in private organization. So, I mean, this poses a challenge, but I don't know whether it's a good or bad, but your thoughts on it and what's the legal framework behind it? Yeah. Right, that's exactly what happened.
Well, did you not notice that my assistant had a British accent?
That's what I was trying to get. Yeah.
And I'm not sure which British accent she had. It wasn't mine, but it was something. She started in Bristol and she went up to Birmingham a little bit. I'll turn that around a little bit. Yes, it can be done, but when we've done roundtables at my college with students, they say we don't want to be taught by. We want to be taught by the professor. We don't want too much personal assistant. We don't want some robot teaching us. So that's the other thing that we need to be careful of, that it still needs to be professor content.
Yeah, but if you're giving lectures and you bring in holograms and everything, I mean, there's no way to differentiate.
Well, if you're teaching online, and teaching
Yeah.
an asynchronous class, yes, you could be teaching all over the place.
Yeah.
And the students are just logging in whenever at 4 o'clock in the morning.
So this WFM or work from home and other things, I mean, this is where we are going to, or perhaps heading towards maybe.
Yeah, it brings up some ethical issues. And
Yeah,
it brings up
okay. Thank you.
Rights to your own personality and voice and appearance and so on. Can a company take your persona and employ you?
Right, exactly.
All right, before we go
let's
down
think
that,
about those things. Just
before we
think
go
about
down that rabbit hole, I want,
That is a rabbit hole. I love that.
Yeah.
We have one more question here. We're going to kick Kai's presentation off at 4:45. Or sorry, not that late. 3:45. We're going to kick Kai's presentation off at 3:45. Time for one more question here. Super quick break, and then we'll get it. We'll get the next section going.
Okay. Hey, everybody. My name's Nathan, and I work as a technologist, data, AI, DevOps, the center of it. But I love this panel because my mother was an English comp teacher, and she was one of those that retired because of all the AI stuff coming through. But my wife is an attorney who does white collar defense too. So as I'm thinking about this, and we have technologists here, so I always think of, well, what happens when something goes wrong? And we're talking about policy and regulation, but there's also that other enforcement, justice system piece of that. So my read on it is, people say this is the Wild West, things are growing so much, but they're really not. This is continued, technology evolution, right? And so what happened in this Wild West when airlines are putting agents out there that are promising free tickets and people are, doing this or that, and we're having educators being enterprising and saying, hey, we've got a chat assistant, but maybe that assistant gets something wrong. And then university system, there's a grievance process, right? Or go to you and be like, whatever, AI assistant. But when we're talking about millions of customers out there, some Wild West, the question for the panel here is, we have the current system of regulation, and I think regulators are like, things are moving so quick, we don't want to put regulations in that's going to squash innovation. So what do you guys think about that, how that tail end would work when something's wrong? So it's not an industrial accident when something happens or people are this or that or free tickets. What does that world look like of regulation? And so that there's fairness in outcomes when something doesn't go right.
So I think I can maybe start, then Sam can chip in. A couple of things that I can think here. One is the maturity of the technology that we are using. So right now, as was again mentioned by one of our speakers, that right now it's like marketing or consumer orientation. That is what is the focus right now for most of these tools. So in those critical, life impacting, life threatening situations, the AI tools are not really, the technology is not, being relied to that level. So that's one part, and that will continue to evolve with time. Second thing is that it has to be like more adaptive regulatory framework evolution also, as we put in the AI tools in more and more different functional areas. So I guess the governments, and supported by the different lobbies and the organizations, so I think that ecosystem has to pretty much also pace up, and AI can help in that also. So I think it's going to be interesting, and it needs to be more collaborative and adaptive is what comes to my mind, to just be on top of where we really need to be. Sam, any other thoughts?
Yeah, well, I mean, it depends on the context. And John Willis got into this before. He said you have to create the right tool for the job, right? So when it goes wrong, somebody dies. Okay, if you look at the grade of automation of the Paris metro system, it's GOA 4. But like I just got a Tesla with FSD, and it's the full self-driving is GOA 2 or 3. And if you're not there hanging onto the wheel when it makes a mistake, right, then you've got you could end up in trouble or somebody else, right? Now they're upgrading that now from a whole lot of kind of more like an expert system of hand cut and C++ code to a neural network, and the next, I think it's FSD version 12, is moving to an AI-based system which is in many ways better than the system that was there before, particularly when it finds things that don't match any of the rules. So we're going to ultimately be better off, I think, by using these AI systems. But if you're going to deploy it in an operating room, it's like, do you cut the red or the purple? You want to get that stuff right. You don't have time to go and read the manual, but you need to train your systems and have controls in place to make sure that they're appropriate for the application. Maybe if you give the wrong answer on an English essay, nobody's going to die, hopefully. So you might have a different, more creative, kind of allow more. You have a different type of AI that you need to deploy.
All right. Thank you, Sam. Thank you for that question. That was great. Panelists, thank you so much. I appreciate your time. It is Kai's turn to have the talking stick.
Thank you.
Thank you so much, panelists. Really appreciate it. Thank you, Brittany. Really appreciate you as well. Dr. Kai Pham is coming up next. Dr. Pham leads our AI and Life Sciences work group. With an MD and a PhD, PhD in AI, he's got a lot of perspective on the biological natures as well as the computational natures of artificial intelligence. He's going to share today a little bit more about causal reasoning, talking about the right tool for the job and what they're good for and what they're not and where things are headed. This will be a fantastic way to follow that up. Looking good. Yeah, we're blowing through our break, by the way, so sorry, no breaks for anybody. We're clawing it back. All right. Yep. Whoop, that looked.
Well, it's trying to get it.
Aspect ratios are causing challenges with the stream. Thank you for the patience.
Is that a remote thing? It should stay here. Okay. Okay. Hi, everybody. Yeah, the title is Advancement in Machine Reasoning. But before I'm going to talk about that, I want to be sure that we talk about the same thing. We talk about a lot of things, the impact of AI, what that can be, what can be the future, and so on. But I would like to say something. The best intelligence we know today is human, right? And human, what do we process? We process data. We process knowledge. Yes? So reductionist. So intelligence on human, we do not process data. I give you a list of 100 people you already lost. You cannot process that. We process knowledge. And the reason why we process knowledge is because knowledge is the most powerful way to compress data. Right? Each time that you acquire a piece of knowledge, it's a result of a lot of data processing, curating, analysis, interpretation. Oh, and now I have this piece of knowledge that I can stick to other piece of knowledge. So how many times you hear the term knowledge when you go to AI conference? Data, data, data. So I'm not saying that, the AI we are doing is not interesting, it's not great, it has potential, but it's not the intelligence that human we think it is. So just do not confuse the things. The other thing is, then why do you process knowledge? Why intelligent process knowledge? Yeah, but what is this process? What would you call this process? Reasoning. Again, when you go to all this AI conference, how many times you hear the term reasoning? Okay. So I really want you to understand that we are really just at the beginning of the era. And when people talk about AGI, it's a joke. First of all, it's not even interesting. What is interesting is the super intelligence. And it's a joke because what you have today with ChatGPT, we will never get there. ChatGPT doesn't reason. It just makes association of things. It brings a lot of great things, but not what the thing that you think it brings. So it's very important to, thinking about the future, the danger, everything, but once we know exactly what we have in hand and what we are talking about. So Pankaj was talking about, AI is like 70 years. I did 30 years of it. So since long time, so I was able to cross the different machine learning and so on. So I'm part of, thank you, Reza, to be on the board of Kwaai, but at the same time, I'm the founder CEO of Thinking Note. So Thinking Note, we are AI biotech company, and more precisely, we are AI digital cell clone. So in any, big industry, right, pharma, aviation, the first thing you do is to have a digital model, so then you can do simulation. In drug R&D, you don't have. People just do wet lab, tests on animals, and then on humans right away. So what we do is, using a new type of AI, distributed reasoning AI, we can generate in 1 hour any human digital cell clones. So we take the gene expression data of your cell, or the patient's cell, we inject it into a model, we generate that. So the generative AI we have is not machine learning based, it's a generative distributed reasoning AI. So yeah, I was talking about intelligence. I like very much this definition from Jean Piaget. Intelligence is not what you know, it's what you do when you don't know. And I add, with rational outcome, because you can do a lot of things, right, that you don't know, but so yeah, each time you see AI/ML, why on earth people always put AI/ML and they talk about ML? So either we are agreed to put ML under AI and we stop to say ML, but it's so annoying. So we have mainly two cognitive systems, pattern recognition and reasoning. And this is a fantastic book, Daniel Kahneman, System 1, System 2. You think fast, you think slow, reactive against reflective, associative against logical, unconscious, conscious. Yeah, because we take about 30,000 decisions per day. Your phone, your things, and so on, but you don't think about it. So everything that you are doing in a second is pattern recognition. Only 5%, because it's painful to think. It's painful to reason, right? So what is interesting is at the same time, you have this dichotomy in AI. First, the physicalists, so we were talking about starting in the 50s, say that, okay, to reproduce intelligence, we have to reproduce neurons because it's the neurons. Right? I prefer to talk about connectionism. It's a real term because a lot of neural networks you hear about today has absolutely nothing with a neuron. I mean, the way it's implemented, there is no excitation threshold, there is no refractory period. it's just not connected with weight. So connectionism is the right term. On the other side, you have computational logic. So on one side, you have data-driven, knowledge-driven, correlation versus causation. How many times, right, you heard that correlation is not causation, but people still confuse the two. And it's so important. This is another book, very interesting book from Joe Dapper, fantastic. He's my mentor. If you really want to better understand correlation, causation, and he's the father of probabilistic network in machine learning and so on. So, we all agree that correlation is not causation. Are we all agree that to have causation, we have to have correlation? Yeah? Are you sure? Since I ask, it's because there is a trick, right? No, it depends on your data. So pay attention to your data. So causation, you can have causation without correlation. How is that possible? So let's suppose I collect data on how crops grow, right? Oh, I can see correlation between rain and the crop grow. I have my correlation. But if I have too much rain, the crop die. So if I have my data all the way, I'm not going to see any correlation because sometimes it grows, sometimes it doesn't grow. But still, the rain is the cause. This means you need to have knowledge. You need to have reasoning. And people who tell you, you know what, I'm going to collect so much data, real-world data, and I'm going to infer causal network, either they don't understand correlation and causation 101 course, or they mislead you. So today we are in the era of correlation, and it's amazing. It surprised so many people what we can do just with correlation at scale. So by the way, imagine what it can do with reasoning, right? So as I mentioned, why we process data is to generate knowledge. But knowledge is completely useless until somebody studies it, right? Library is full of books. So you have to study it, so then you can use reasoning. And with all the technology, we have more and more knowledge. We still don't solve the knowledge bottleneck. And everything we are talking about mainly is about the data, but we don't talk about the knowledge. So it's where knowledge-driven AI come in. But why you don't hear much about it is because most of the approach are centralized, which means you have one reasoning engine for different type of knowledge. We reason between analogy, constraint, probability, case-based. We switch, no problem. So if you have one engine, doesn't work. So I work on distributed AI for almost 30 years now, where each node is a mini reasoning engine itself. Okay? So from there, we have the two generative AI that I was talking about. So large language model. Here, I'm going to take another example and in biology. When you want to understand the phenotype of the cell, you look for the genome, you look for the gene expression. But if you have a gene association with statistic, you see the association, but you still don't understand what's going on. You don't understand the mechanistic, the causality. On the other side, if you have causation, then you can understand the gene interactions. And this is very important because then you can know where to, hit, because you understand the causality. So this is just to give you a quick panel of the different type of AI approach. So it's not just ChatGPT or just machine learning, right? And in AI symbolic, the reasoning, you have production rules, very old system. You have constraint programming, you have natural language processing, but the old way. You have case-based reasoning, you have semantics network, you have logic programming. Prolog is a fantastic language for that. You have planning and scheduling, you have frames and so on. So there are a lot of different approaches. One of the approaches that is very interesting is the multi-agent approach. It exists message system where the agent interact with message. And then blackboard, where the agent just notice what's going on the blackboard. So suppose I'm agent A, I need something, I just put on the blackboard, so then the agent B say, oh, hey, I know how to solve that. Then macro connection is, I'm going to talk just a little bit later, and you're going to see why. So we talk about the advancement in reasoning. In AI, advancement take a lot of time. As you can see, 70 years, right? So today people start to talk about neurosymbolic AI. So this is something I found on the internet. A lot of things wrong here. First, it should be the other side. What I mean by that is symbolic brain do not analyze music. It's the pattern recognition. You recognize a piece of music, right? So combining the two, what people are doing today, at best, is to combine two different systems from statistical system and symbolic system. Now, what if we can combine that in one type of AI? So this is the research I did for decades, unified cognitive AI framework. And it's about, so this is the publication I published 30 years ago. This is the first generation on how to combine the capacity of learning, of symbolic reasoning, and so on. And it's called macro-connectionism. So tomorrow I'm going to have 1 hour talk. If you're interested to have more about it, I will more talking about the life science. It's at 11:15 in ballroom F. Thank you very much, and see you later.
Thank you, Kai. That was great. Reese is back up next. He's going to do an abbreviated show here, get us inspired by some physics-inspired neural networks. Kai's all about the biology, and Reese is all about the physics. What we'll wrap up here, we have one more panel after this, so it'll be an opportunity to ask some questions. John Willis is also going to be coming back for that panel. It's really the fundamentals panel as well for some of the science in the background. So go ahead and stick around and make sure you ask some questions there. After that, we'll do member voices. This is a great opportunity. If you don't have a question, but you have an observation, you want to make it known to the Kwaai community, that's what member voices is for. So we'd love to hear from you at the mic. And then after that, the Kwaai party. And I don't have my little things up here. Oh, here we go. We're fun, so we have some wristbands, but we're cheap, so we also have drink tickets. But a great time to donate on the website, by the way. Head over to the Hotel Dina at 5 o'clock. We're going to have a mixer. Great opportunity just to get face-to-face with these folks and each other.
Great, thanks everybody. Hey, you're still here. Okay. We're going to nerd out. We're going to nerd out because you're all nerds. Today's Pi Day. Did anybody? Okay, you got that. Great. Okay, so I'm going to take you deep under the hood. We're going to look at AI fundamentals, but not just a 101 on AI. This is a different way of doing AI, a different approach to make models smarter, faster, and greener. This is all super important. What's the motivation? We're going to cover this. In fact, I'm going to skip over the agenda. We'll just go and do it. Okay. As I mentioned, 3 tracks to what we're doing: the tools, the fundamentals, and the policy. You heard about the other 2. This is about the fundamentals. The big problem with our neural networks are, compared to this 2-pound biological computer that we carry around with us, that can learn and think concurrently. That's not what deep neural networks do. Deep neural networks, large language models as well, you have to train in one massive instance, release the model, and then run inference in another engine. So that's one strike against it. It's so compute intensive. We've got a portable machine we're carrying around with us. It does far more thinking than the biggest data centers filled with GPUs. And the third point is it takes so much data. A young infant can learn to recognize faces on so few samples compared to the facial recognition models that I've been training in my previous job. Millions and millions of samples are needed before the model converges and gives you a level of accuracy. So recap from the previous summit. No, watch the video. I'm going to skip through that. Okay. I want to follow on from what Kwaai talked about causality. And that's my line of inquiry about, can we make neural networks that actually are not based on correlation, but based on causation? So when you look at this as an existing neural network, every node in one layer is connected to every other node in subsequent layers. It's basically saying, I mean, it's at the height of intellectual laziness to say, I don't know how to solve this problem. I don't even want to think about it. I'm just going to use historical data and ground truth, and I'm just going to throw it into the model and see if it can give me answers. And the sort of the bloody mindedness in me, I think to myself when I see a problem, I think, well, how hard could it be? You know, we're going to figure this out. Okay, so last summit I posed the question, what if each of these nodes in the neural network was instead some sort of physical element? And I chose a fluidic model. This is actually not a crazy thought. There's a whole body of research called PINs, physics-inspired neural networks. Some people call it physics-informed neural networks. I like the word inspired. Okay, so that's where we're going to dive into. And if you want to get a primer on this, if you want to get up to speed on it, Steve Brunton, who's at the University of Washington, has got a great lecture series on YouTube. Go and check out what he does there. He looks at a problem. He says, well, is that similar to some sort of physics model? Let's take the equations from that and let's go from there. Let's have the laws of physics actually determine the weights of the model and all the other sorts of things. Okay. I had a different area of exploration. Where is Kwaai? Is he left? Oh, he's right there. Okay. So that what happens in Vegas, Kwaai, yeah, it doesn't stay in Vegas. It comes home with you and haunts your dreams. So, or sometimes they come home and they call you dad later on. Okay. Okay, but Kwaai and I were at an AI summit last year sometime. And he explained to me, he gave me the primer on reasoning AI, and I told him, well, I've been thinking about a different type of network, and I've been talking about, hey, I've noticed a striking similarity between quantum mechanics and artificial intelligence, between the type of network that exists in our idea of quantum theory and the networks that exist in AI. At the left-hand side, you have an input, and at the right-hand side, you have an output, and in the middle, you have kind of this cloud of probability. And you have vector math that has these affine vectors. Affine means they all sum up to 1. Okay. And they've got the same sort of throwing their hands in the air attitude that we don't know what goes on in the middle, but in the case of Richard Feynman, shut up and calculate, actually not misattributed to him, but I think he espoused that same philosophy. We don't know why it works. Here's the math. Just go and do the calculations. Geoffrey Hinton, when espousing the math of deep neural networks, also says, hey, I don't know why it works. Just equivalent of shut up and calculate. Just move forward. Forward is his pivotal paper. Okay, quantum mechanics and AI wave functions. I'm considering a fluid that spins. Okay, and it's a Newtonian fluid, and I'm pondering on how can we model the velocity field around a single volume element of fluid. How does that velocity field propagate? And of course, in order to do that, I need to simplify the model because I don't want to solve the Navier-Stokes equation. So I'm only considering orbital motion, and I'm taking a slice through a 3D model. So it's reducing a 3D model to 2D, and I'm only looking at the wavefront. So not the entire fluid in all of its glory, in its stable state. I'm looking at the wavefront that propagates that from the central volume element, and start off where the entire fluid is initially quiescent. And so when you do that, it turns out that the Navier-Stokes equations can dissolve into simple matrix math. Okay, simple arithmetic that we can do in high school. Okay. And I did that. And actually, it's not something I just did after the conversation with Kai. It's actually been something I've been working on since about 2005. Okay, so rather than bore you with the math, I'm just going to give you a simulation of it. Okay, so up it pops, and we're going to go here, and we're going to make it big or go home. Okay, so you're seeing here a spinning volume and a cloud of probability, and I started off spinning with an angular velocity of 1, and it decays almost to nothing, but then builds up again and ends up at at 1 again. Okay, that's using simplified physics. I then did it with a more exhaustive complex physics, and I end up with this. Okay, so you can't see what's going on there because I'm going to zoom out and show it to you at that resolution. Okay, so this is interesting. And what's going on here is the spinning volume, and there's something familiar in the cloud of probability that emanates from that initial spinning volume. It looks like something we've seen in physics elsewhere. Okay. So I look at that so the redness of it is the orbital velocity of this fluid. And because I've taken a 2D slice through it, it looks like a matrix. Okay. I know what it is because I've been studying this in physics. It is in fact, so there's the energy view, there's the angular momentum view. But what I do now is I rotate that through 45 degrees. And I look at, let's just zero this out. I look at how the wavefront propagates in time. So this is looking at one lobe. The wavefront propagates in time, and it moves along and then reaches 1 again here. So I don't know what to make of this. I think it is the observable at either ends, and the middle part is a probability field. And so this is the amazing thing is, I'm gonna kill that, and we go back to the presentation, and I'm going to wrap up here where we talk about exactly what the implications are. Okay, so the results are you get these two lobes propagating from this flowing volume element, one going off at 45, the other going off at minus 45 degrees. Well, because it's a slice through a 3D volume, it's actually representing a vortex, and it's actually two lobes of a vortex. The momentum and the energy build up on the wavefront. Okay, so in the full slice through the entire 3D model, it looks like that. Looks very familiar. Looks like the sort of clouds that you get around an electron or something like that. And it turns out that is in fact what it is. This is all built on a separate thought experiment in physics around fluidic space-time. So, but what is the application for deep neural networks? What does it mean? It means that you've now got a physics that can determine the value of the weights. You don't have to learn them. I mean, that's the whole point of PINs, of physics-inspired neural networks. But this type of neural network, because it's a causal neural network based on physics and only based on local interactions, where one volume element is engaged with the adjacent elements only by the contact surface, it means that you've got a dramatic drop in computation complexity to compute the network and how the network evolves. You only need to look at two adjacent nodes in the next layer. So you reduce the order of complexity to order n rather than order n squared. In a deep neural network of today's logic, let's say you've got 1,000 nodes in one layer, 1,000 nodes in the subsequent layer, you'll have 1,000,000 connections between them, so 1,000,000 weights. This one, you'll have n weights. It turns out you actually only have 2 weights, and you run them down. So if I was to build this in a chip, I'd have one register, and then a register for the next layer, and I'd run that processor down there doing simple multiplies and accumulates, only 2 and 1 add to get each element, run it down, and then load the result back into the first register. So what does it mean? Well, we can ask our AI, what does it mean? Actually, if you ask her what is a fluidic model, she'll quote from the RAG data we gave her, the script from the last summit. How do we train it? Well, I don't think we do train it, because the weights are based on physics. But how do we pose problems to it? I don't know. It's almost as if, I don't know, I've stumbled across an abacus and I don't know how to ask it questions. So that's the area of where we're going. Look, next steps are, there's still math I need to do. I need to normalize the matrix math. I think I know how to do that. I'd really love help in simulating this. It's a rotating field. Love to animate that. Love to run some experiments. I'd love to explore the implications of that network actually being a qubit, and explore the behavior of a fluidic neural network. So that's part of what we're doing. On the area of physics, this is actually the fluidic space-time actually unifies quantum mechanics and gravity, but I'm more in the line of the Grinch, where he said, solve world hunger and tell no one. Maybe I'll do that. I've already got a ban on Reddit for talking about this. So the physics community are not as open as the computer science community to new ideas. But hey, why not join Kwaai, join the Fundamental AI Research Group, and we can do this stuff, and we can do some exciting things. Okay, thanks very much. I hope we've caught up some time. Thanks.
Thank you. Thank you. All right, we've got our final panel. Brittany, I'll invite you back up here. Riza, you stick around, grab a chair. Also, John Willis, thank you for participating in the fundamentals panel. You get fundamentals with a lot of this, sure, why not? And Kai Pham, thank you, and Rahman. Is Rahman here? He said he might have a key. All right, he's not here. We're just gonna leave a chair in his honor.
Hello, everyone. Hi. There is a conversation. Yay! Hi, audience. Welcome. All right. Who are we missing? Roman. Okay. Do we have the microphones? No. It's right here. And
yep, we do.
Cool. Getting the hang of it. Getting the hang of it now. Okay. Yeah. Or the fourth panel today. All right. So we're going to get started without Ramon. And unfortunately, we won't be able to say what's up, Doc. It doesn't work as well with that. But anyway, I digress. I'm sorry. Okay. So I didn't say this in the second panel. We're going to open it up for questions towards the end. If you have a question, whenever it comes up, get in line. The microphone is over there. Get in line just so I have an idea of how long I need to allot for questions at the end. It helps me out. Thank you. So this is our fundamentals track. Hi, panel. Thank you for being here. Appreciate you. I, as an engineer and a creative and not a physicist, would love to have a conversation with the fundamentals panelists about how alternatives at the fundamental level will affect personal AI user experience, and just from a consumer level, how is what you're doing very low end going to affect the people using the technology. So, Reza, I'd like to start with you and start with your work on fluid networks, fluid network models. And how can fluid networks help personal AI specifically? Will they will we benefit from a UX perspective, or is it more performance based?
I think it's more performance. I think what my motivation was twofold. One was an efficiency. Is there a more compute efficient way of running neural networks based on the laws of physics? And ultimately, I think there is a part, that thing I disparaged and said is intellectual laziness. It kind of is. But there are parts of problems where we really don't have the mathematical formula behind it. And there's no rules and procedure, no sort of formal stepwise method of solving a problem, but we've got lots of data. So I think it ends up being a mix of the two. I'd love to create a tool that'll take a deep neural network and break it down into a causal network and a probable network. So it's a causal network, which would be based on laws of physics or some other set of defined laws, and a probable network, which will be basically a smaller version of the initial model. For instance, a large language model. Well, so what are the rules? What is the physics inside language? Well, there's grammar, there's syntax, there's an established dictionary of vocabulary. Those are formal. Those are formal and algorithmic. It's not based just purely on correlation. So you could actually take an existing large language model, decompose it into something that's a causal network and one that's a probable network. And that's, I think, what could happen. The ultimate result is it'll take up less computation and could possibly run on a mobile device, on a wearable or something like that. John.
Okay.
So I'm going to start with, in the early days of cloud, they put me on a panel, and I didn't know the guy next to me had did the sequencing of the DNA. So I argued with him. And then I got off the panel, and they told me, did you know who that guy did? But this time I actually know I've got 2 billion guys besides me, so I feel like an imposter right now. No, I think that my point is, I'm not a data scientist. I didn't get a degree in AI. I've been sort of crawling my way out of this sort of what this thing is. But for those of you who saw my presentation, I'm looking at the practical implementations of how this stuff, it looks like I missed your amazing presentation, but I'm a big fan of Daniel Kahneman, thinking fast and slow, the neuro symbolic, the structure which seems like it's built on that. I think a lot of the things that we think about, is like how do we turn data into sort of information, which turns into knowledge, which turns into understanding, which may be wisdom, I don't know. But the point being, there's so much data in an enterprise. The IDC did a report last year, an analysis that said 90% of the data in an enterprise, an organization, is unstructured data. And so we spend 90% of our time trying to wrangle the 10%. The real advance here, the things that I see that these LLMs or these neural networks, or the way that we can sort of compose this data into something up the chain, is that's the voice of the organization. The way an organization, like, you know, if a certain organization is really good at channel partners, if another organization is great at supply chain, that's all that 90%. That's a tacit knowledge. It's the knowledge that Sue has in a spreadsheet, Bill has in an email. It's communication vehicles. So if we can tap into that in a way that allows us to sort of to understand our organization and our strengths and our weaknesses, I think, you know, and I think just catching your presentation, I think there's a tremendous opportunity. Because one of the things we do in DevOps is we try to, not through sort of science, but try to figure out what these pockets of ignorance. What's his face? Paul O'Neill called them pockets of ignorance in an organization, right? If we could use some type of network like that, or the neural symbolic networks, to help us find out where our sort of strengths are and our pockets of ignorance, I'm all in.
So Kai, I actually want to change up the question for you actually a little bit. Sorry. I'm curious, like, based on what Reza said about fluid networks and what John just said about LLMs and how they can sort of probably be broken down to do both things, what I want to ask, do you think reasoning models will replace LLMs, or will they coexist? Or is there, yeah, what do you foresee in that light?
The end game is to have reasoning. The end game is to have knowledge. The end game is to have causation. Science is causation. So if today we have a perfect reasoning network on medicine or whatever on text, LLM is completely useless, because reasoning is logical, rational, not biased, and it's built on top of the data. So yeah, there are a lot of data, but geez, why don't we process knowledge? How many of us have, in our domain, we know only a very small piece of it. So if we just connect the whole dot, we will jump in terms of progress so much faster. I'm not saying we should not process data, but it's mining. It's like rock, and we have gold, and we don't use it.
That's great. I love that.
That's where I get myself in trouble. I mean, isn't bias part of the reasoning? So you said not to have bias, right? But bias is not necessarily a bad thing, right? I mean, the symbolic nature. Okay, anyway, yeah.
I didn't mention bias. I was saying exact. We cannot get rid of bias. Quantum mechanics told us that, right? As soon as you observe something, you already bias it. And interpretation is bias, because it's how we interpret it. So when people are chasing to have zero bias, it's nonsense.
All right. Okay. I had this question for Roman, but John, I think you might be able to have some insight on this. Do you foresee challenges in as engineers adopting different fundamental models in open source today? Like, is it easy to do, or?
Yeah, I mean, what I worry about more is sort of from the sort of, you know, my whole career has been infrastructure and operations. I grew up, you know, I started my career running large mainframes, you know, then distributed computing. And what I see, so there's a little diversion of the answer, because I think these two guys are way more qualified to answer the network, the AI answers, is what I call the technical debt tsunami that is coming down the pike, that the CIO has no clue is going to happen. And so part of my workshop this morning, part of that short presentation, is to make aware the people that manage infrastructure and operations, if we call it DevOps, we call it DevSecOps, doesn't matter. We got to educate them really quickly. They have to understand what the terminology is. Because right now, groups like HR groups are coming in and dropping in these models and all these different ways of doing things that changes every 15 minutes. And we, like the collective we, if you're going to DevOps days tomorrow, we don't even know what questions to ask. When our CIO is asking us, what do you think about this solution? You know, when cloud came around, like, it was a little bit of a bump, but we knew network, storage, and compute. like, okay, I get it now. Cloud is just network storage compute. I'm on board now, CIO. I have a feeling right now, and I'm racing to catch up, that we don't really know what the components are here. And like if we blink, and hey, dear CIO, we're writing a paper now called Dear CIO, which is going to be a plea to them to say, you have to educate, you have to get involved, and you need to start asking questions, because if you don't, you'll have 30 different variants of models that people use. You'll have 30 different variants of orchestration engines. You'll have 50 different vector databases. And they'll all be like a tremendous amount of like and I'll shut up here in a second, but like I thought Ruby Gems was a disaster. The dependency map on Python libraries in this generative AI, I'll have something that worked for 2 months. It'll break on a Monday, and I'll get 6 pages of a stack trace of some library that's written by some PhD student that, and like, this is the world we live in. It is brittle, and we're going to have to manage this stuff because there's no stopping it. It's coming down, it's happening. And so I think our job is to get as educated, learn as much as we can from people like these, and really get educated and try to figure out what we can bottleneck and what we can't.
All right, thank you. And I'm curious, since Reza and Kai are actively in the community, I'm curious what your outlook is for adopting these fundamental models, or just sort of using them in the Kwaai community. How far is that outlook? Can we do it now? What can we play with?
Well, I think it's much needed research. I think we're showing that research is possible in this area, and it's needed. Look, part of the nightmares, the thing that haunted my dreams recently was the vision of a big landfill, a $7 trillion landfill. Okay, so you know what I mean. The $7 trillion landfill, based on this addiction on GPUs, that it's the height of intellectual laziness to say we don't know how to solve these problems. If a fraction of that was spent on working on causal neural networks or reasoning AI or smarter ways of doing things. John, you mentioned something, and it probably went over. You mentioned it really quickly. The cosine similarity. Okay, so what happens in neural networks is this matrix math. And a mathematician would recognize it as the dot product between two vectors. And what Geoffrey Hinton said, no, you just have to look at the similarity and just move forward. Don't worry about the difference. So the cosine between two vectors is measuring how these two vectors are aligned. And then we just go forward. And we go all the way through to the end of the network and realize, oh crap, there's a big difference. Now we have to go all the way backwards through backpropagation. There's better math. Use better math at each node. So geometric algebra computes both the alignment and the misalignment. Hey, if you were to do that, maybe you can get a network that learns as it thinks. So that's another area of investigation, using geometric algebra as the fundamental math in the perceptron, rather than just this lame dot product. Why do we do that? Because it's easy to compute on a GPU. And it's a self-fulfilling prophecy that GPUs, which were designed for video games, for shaders and rendering graphics, okay, it got other uses. People figured out how to mine Bitcoin on it. And now they've figured out how to run deep neural networks on it. And yeah, one company's getting super fabulously rich on it, but it's just fundamental intellectual laziness, not thinking of other ways of coming up with AI, implementing AI. Get off my soapbox.
And so, I want to hear from Kai. Sorry, but do you have a question? Are you all right? We're going to hear from Kai, and then we're going to move to you. And anyone else who wants to ask a question or make a statement can go up to the microphone. All right.
Yeah, so the macro connectionism that I was talking about, as I mentioned, I work on that for 30 years. And the reason why, so I started to publish But I realized that in the academic world, if you are not in the right trend, people don't listen to you. You have to mention papers that you are fundamentally not agree, because if you don't mention them, your paper is not accepted. I thought that the academic world was very open-minded, and I know it's video, but I will not return to academic world anyway. I wish the academic world really is open-minded place. So from there, I decided to build companies to prove that it works. So my first AI company was very successful, and this one we started to have a very interesting traction. So the technology is no more like we don't know what it does. It's already have result. And I'm interested here to, it cannot be open source because there's a company behind, but I really want to find a way to open it. So I'm here to open to discussion people who would be interested to work on unified AI, having the machine learning and the reasoning based on macro connectionism. Please come to me and we can talk, because I think this can help other domain than the one I am, which is life science today.
All right, great. Can we have your question?
Yes. Hi, I'm Adrian, the middle child, and I came all the way from San Diego to ask Dr. Fan this question. So, yeah.
There are Zoom.
So it's about explainable AI and if it should be a litmus test. My example is a documentary on the Challenger flight. And in the story, they explain that the program manager in Washington demanded that they launch because they'd become late and behind schedule. But that was at least someone being accountable and explaining it. So should explainability be a litmus test for AI?
So this is another misunderstanding topic. What I mean by that is you need to explain something is because these things is not clear. What I mean by that is you need explainable AI because it's a black box. But if your AI is already explicit as a human, right? If you tell me something, my first reaction to you, if I don't understand, I'm going to ask you why, and your answer is B cause, B cause. And then you're going to explain me what's going on right away based on how you do your reasoning. So explainable AI is needed when you have a black box system, which means mainly machine learning. The reasoning, a lot of time people say to me, okay, but what is the mathematics? What is the algorithm? No, with reasoning, you have an intermediate level, which is the knowledge level, the conceptual level. You don't need to go underneath to understand what's going on. If the knowledge level, the conceptual level is logic and rational, and this is how human we function. So explainable AI is super important, but not maybe the way that people think is to solve a problem because the system is a black box to start with.
One thing in that example, you know, I've studied the Columbia, and not from an AI perspective, but the Columbia and the Challenger postmortems, and I've done a lot of work on, you know, safety and resilience culture. There's been probably 15 books trying to explain what happened with Columbia. Diane Vaughan wrote a book, Normalization of Deviance. So whether it's AI or it's humans, explainable is a bias, right? So like, and you know, like I've been running a lot of sort of observability tools, like evaluation tools, and I've noticed there's this sort of phenomenon that I'm calling hallucinations of hallucinations, right? Which basically, and it sounds funny, but it's like I'll see something where it tells me it's a hallucination and it's the wrong answer, but actually for the corpus of data I'm using, it's the right answer. I found other scenarios where these hallucinations are telling me I didn't give as good of an answer. So again, that's just another form of what it's not, these are not AI terms for a non-AI guy, but they're biases. And so I think to sort of equivalate the notion of like humans give great answers when we have tragedies or wrong scenarios, and AI is going to have to do the same thing. That's incorrect. Humans do a terrible job of explaining disasters and You know, and think about all the sort of mental models that go into how you sort of decouple something that happens, like you know, the Challenger, Night Capital, you know, all these disasters.
Just one quick things here. When you talk about explanation, the next concept is understanding, right? You accept an explanation only when you say, okay, I understand it. Now, what does it mean, understand? Have you think about why suddenly you say, I understand, but what does that mean? It means that you were able to connect some of the new concept to the concept that you have. And you cannot do that with just notes that have no meanings.
Thank you. And we have time for one more quick question, and then we're going to move on to member voices. So we'll have everyone will have another chance to speak in a few minutes.
All right, I have just 2 comments, and I want to get the panel's view on what I'm going to talk about. The first thing is on correlation, and I think and causation. I appreciate that there was some talk about the difference, because there's major confusion even in higher circles that I see. First of all, some people think that if there is no correlation, then means no causation. That's totally false, as it was pointed out. Others think that correlation is necessary but not sufficient condition for causation. That's a little bit better, but even that is false, because correlation indicates only a linear relationship. So even if it's not correlated, the relationship could be more complex, like curve or space or other things. So those is one more reason to go for intelligent reasoning. But at the same time, I want to point out that I'm so impressed with the work that both Reza and Kwaai have done, and I hope that it's going to advance more. But I think even if we get more, that doesn't mean that there is no value for machine learning, neural networks, and all that, because there's some things that are happening, some phenomenon that we have no idea what are the factors that are causing it. So machine learning and artificial intelligence could point out that there is some relationship so that it will direct the more advanced science-based people to go after and find out the causation. So there is still room for both. That's my point of view. And I don't know if the panel agrees or not.
I just want to rebound on your comment and what Reza was talking about, the $7 trillion things, right? Yeah, machine learning is great. It does amazing things. But you can put this money into some much more efficient and smart way to do it. This is the thing. So the voice I can try to say here, hey, people are looking here, but geez, there is something here that is easier, fast. Oh, it can be complex to do it, but as a result, it's way more efficient.
So you all know the $7 trillion reference. That's Sam Altman's ask for, I need $7 trillion in order to build the data centers for my AI ambitions, or build new silicon to compute it. But I'm not sure that a fraction of that spent on something else. What are you? There's another question, right? Okay.
And that's very kind of you. Yeah, just one question, and actually just want to resonate with the group. You guys have heard of Eleuther AI, that they've offered a lot of data sets and things of that nature. So Eleuther AI did a study on actually what corpuses of data are actually utilized in neural networks, and they said that 92% of the data is not used 99% of the time. So I think that resonates with exactly what the gentlemen are talking about, that there's a signal versus noise. Now, the structure of the neural networks and how they're used,
that's something for the, the theorists to do. But I just wanted to resonate with the group and maybe get some feedback on that. And if you guys haven't seen the study, take a look at it. But yeah, right now they're using brute force, to your point, with the $7 trillion worth of GPUs, because we don't know where the signal is at, right? And so we're compensating that with brute force. And that was very kind of John Willis, but he's been, I've been a big fan of his for well over a decade, but he's an amazing guy.
When you say we don't know, so we do brute force, yeah, and we'll continue to do not know by using the wrong tool. The other thing is the $7 trillion. Even the thing itself is just crazy. Imagine how much today Microsoft saw 30% increase of their electricity consumption because of AI. Imagine $7 trillion in addition to that. Are you sure that our planet is going to handle that? Okay, so there are so many elements. So for me, it's more like an ego trip rather than a real market. Because maybe you can start with 1 trillion.
Actually, on that note, we're looking for contributions of equipment. So I don't know if Michael Larson's in the audience. Michael loaned us the Beast. So for quite a while, we've been running on his machine located somewhere in San Bernardino. Yeah, it's expensive to run these GPUs in the cloud. And so you're not going to get a movement to get you off the cloud. And that's not going to come from the hyperscalers themselves. They would love you to continue doing your computation in their cloud, and you pay the toll. Oh yeah, just upload all your data here, yeah, and we'll pay you a toll to go and visit it as well. So it's urgent. It's vitally important. It's a clear and present danger. The carbon footprint of today's AI is just disastrous. And so this is one of the areas we could have just purely focused on policy or purely focused on personal AI. The fact that we kicked off a research group to find better ways of doing neural networks, better ways of implementing AI, I think is answering a clear and present danger that AI represents today. How are we doing for time?
We have to wrap up. Okay. That was a wonderful conversation. I do want to. We're doing member voices next, so you will have a platform to talk.
Quick question for the panelists? Or no, I just wanted to share something with everyone.
Great segue. So, thank you, panelists. Really appreciate that. Very, very, very well done. This last part is my favorite part of every one of our Friday meetings, which is our member voices. And you don't have to be a member, although please go sign up on Kwaai.ai. We'd love for you to become one. We'd just love to hear from you, your thoughts, your opinions, feedback, questions, concerns. This is more of an informal session, kind of you to the group. Please, feel free to introduce yourself. I'd also just like to make a quick additional announcement again, and then I'll plug this in and see the thing. Come over for our mixer. We've got some fun little wristbands for you to visit the mixer. You'll hand those out to people. Thank you, Jordan. Appreciate that. He walked up, so I'm trying to delegate here. So yeah, please head over to the Hotel Dina afterwards, 5 o'clock till about 7-ish. We're not feeding you dinner, sorry, but come and hang out with this great group. So yes, would love for you to kick us off with member voices, please.
This is after a long time away from SCaLE because of COVID. This is my first time back after COVID, but I just wanted to let everyone know that on April 10 of 2021, God showed me how to make an AGI machine on a single high-end desktop without using any large language model or anything like that. And when God showed me that, I was afraid to do anything with it for quite a while, but I've now decided to pursue it, and I have a website, jcartes.org, and I've written some basic ideas in an article there, and I'm planning to further develop this machine. And I'm using PostgreSQL as the starting point for writing the code. But I believe that it's possible to use a single high-end desktop without using any cloud storage whatsoever, and to produce an actual AGI machine that's local on a single PC.
That is fascinating, and you'd clearly be a good addition to our fundamentals work group at Kwaai. We'd love for you to sign up. We have a Slack work group. This is how we keep things up asynchronously. Lots of Slack channels going on. That fundamentals work group meets once a week as well to discuss these issues, and really focused on exactly that. How do we make these smarter, greener, and more efficient? Because if we can shrink them down to the size of a high-performance computer, if we can shrink it down to a device, then we can expand access. And so if everybody's got AGI in their desktop, not just a little agent, that is conducive to the democratization that we're trying to do here.
And the other thing is, when you talk about AGI, you have to realize that it cannot be controlled. There are two laws of intelligence.
We've got some folks behind you, so we can move on, and that's great mixer conversation as well. Let's get into that at the mixer.
All right.
Hey, Karsten, you've got.
Yep, just a quick one. Sure. Hi, my name's Karsten Wade, and I'm a person who digs in a lot about open source practices, best practices, and how not just how and what to do, but the why of we do things. And one of the things that's been really concerning me, not just with Kwaai, but all over, is the loose usage of the word open, and whether we talk about open source AI, whether it really is open source or not, and whether that matters. There's one viewpoint is, well, all of these licenses under Llama, for example, are really only going to block big companies, and it doesn't matter. It's not going to ever affect a small person like me. Well, maybe not. But one of the reasons why, et cetera, et cetera. So I have lots of things I thought about this. I'm curious if anybody else wants to talk about these topics. I just wanted to flag up and say I'm interested in it, and I'll be around at the mixer later. Thanks.
Yeah, absolutely. And Karsten's been a great member and community organizer. He also was the principal community architect for Red Hat for some time. So great person to know and understand how culture and technology fits together.
And he's speaking on Saturday.
Yeah, plug your talk.
Yeah, plug the gig.
SCaLE talk.
5 o'clock tomorrow.
Oh, he's doing a panel at 5 o'clock tomorrow.
Panel 5 o'clock tomorrow. Karsten Wade. Jordan.
Yeah, hi, my name's Jordan. I saw Reza's Kwaai talk at DataCon in August and was blown away. Made a few introductions, and here we are. Thank you, everybody, for coming out to the Kwaai Summit, and thanks for all the Kwaai folks for making this thing happen. Yay. And as far as plugs are concerned, I host another co-located event called DevOps Day. It's tomorrow, Ballroom D. See you there. And if anybody needs a drink up ribbon, I got you. But thanks.
Thank you, Jordan.
Hi, my name is Sean. I'm a big fan of Kwaai, and thank you, Reza, for making all of this happen originally. And so I just wanted to plug a talk that I'm giving tomorrow morning at 10 a.m., which is entitled AI Recipes as Public Infrastructure. And so basically, it's a lot around how do we abstract the programming models such that many organizations can partake of these things. And so we'll talk about, in particular, how this is playing out with a bunch of low resource languages and some work that we've been doing that was demoed at the UN in April around farmers and how they're basically using RAG-bots in many different languages, and then really allowing those things to be recycled and reused for many other organizations too. And so I feel like the merger of some of the concepts of these very high-level abstractions and all the great low-level work that you guys are doing in Kwaai is a place I would love to discuss. and hopefully have that happen. Ciao.
Yeah, thank you,
So
Sean.
10 o'clock tomorrow morning.
I see some familiar faces I usually only see on a Google Meet. I'd love for a few of you to come up to the microphone, introduce yourself. Some of the Kwaai
I
members.
can bring the microphone over to you if.
Yeah, or we can bring it to you. Well, one of the traditions is if you don't volunteer, we start asking.
Yeah.
We start calling on people.
Actually, I can think of one. Nathan, why don't you introduce yourself?
Sure. So
Excellent.
I'm Nathan. I've been playing around a lot with LLMs since they first came out, and I'm definitely excited to hear about Kwaai. Let's see, since I have the microphone, something I think is particularly interesting. I really enjoyed Bruce Schneier's talk on privacy and trust. My background's in AppSec, so I always find it really fascinating to find that intersection. I think in general there's a lot of very difficult corporate incentives that really aren't aligned with a lot of incentives for how AI could work well for society. One thing I think is very interesting to think about is the potential of actual agency and sentience. The general consensus is not really a thing right now, but there was a really fascinating talk by David Chalmers at a Philosophy of Mind conference. And I think in general, there can be a lot of things that corporations won't really want to look into because it's very misaligned economically. And the open source community, I think, has more of an obligation to actually do that more in-depth research and answer some of these hard questions.
Hey, and plug your day job website. It's pretty cool.
Sure, yeah. I'm the CTO of a small healthcare mental health art gallery called the Giving Gallery. So it's kind of like Etsy, multi-vendor marketplace. We sell artwork and a percentage of the proceeds go to mental health charities we're partnered with. We just partnered with Children's Hospital of LA last week, so it's pretty exciting.
What was that called again?
It's called the Giving Gallery.
Very good.
The Givers.
Okay, Matt, you want to?
Michael, would you say hello?
Raise your
Oh,
hand.
sorry. Oh, Eunice. Yeah, you, but Eunice.
Where? Right. Oh. Hey.
All right. Okay.
Nice to meet you.
Thanks for raising your hand, Eunice.
You'll pay for this, man. Well, my only job is to make sure that Kwaai has enough resources to produce the open source software. Actually, the people doing the work is the people of Arcus, Anna, Roman, and Sai, and a few other people. But I'm a big fan of the concept, big fan of the movement based on ethics and serving the community, so we don't make the same mistakes that we have made with the mobile phone, with the internet in general. So I appreciate the opportunity and looking forward to meeting all of you. Thank you.
Thank you so much, Eunice, and thank you so much to Arcus Nexus. Eunice is the CEO of Arcus Nexus, Kwai's development partner. They've donated these amazing AI engineers for us. The quid pro quo is that these amazing folks are also getting some great training from some other amazing folks. So if you're working with a services organization and you want to join the party here, we'd love to have you in that way as well. We're about 3 minutes to the 5 o'clock. We could take maybe one, possibly two more hellos, and then I'm going to switch it over to Riza to send us out. Well, send us over to the Hotel Dina. Oh, yeah, here we go.
Oh, sorry. Thank you. My name is Ty. Riza, excellent presentation. You talked about causation and not correlation, and then you also mentioned a causal neural network. That whole concept of causation, particularly around business, the whole MMM, the marketing mix modeling, which every Fortune 500 company uses. For MMM, an MMM is simply a statistical analysis as a multivariate regression on sales and marketing, and multiply times a series of data to estimate the impact of various marketing tactics on sales, and then they forecast them over the period of time. Every company does this. They're all wrong. They're all using correlation. I look forward to figuring out a method of having a causation or a neural network to actually put that into action that several companies can actually predict sales as opposed to just simply lazy.
Good question. So Ty, I'm going to take that one, and thanks so much for coming to the conference. I'm going to take that one and then take us into a wrap up. Okay, so yeah, my talk was about going back to physics to solve some very fundamental problems. Of course, if a tiger is running towards you, you don't have the time to think about Newton's equations of motion, what speed it's coming at you, and the aerodynamics of the hair going through that. No, you've got to think quickly, and that's the slow thinking and the fast thinking. So we've got one part of our brain that's fight or flight. It's a trigger reaction. Is that person a friend or foe? And then we've got a higher level of our brain, which is a bit more socialized. It's a bit more cerebral. And we need both those forms of thinking in our artificial intelligence. This is real intelligence, artificial intelligence. So when we're creating it, we also have to make those snap, blink decisions on certain things. And sometimes let's be in control of those blink decisions rather than leaving it hidden inside training data and so on. So it's the thing we call bias. It's a deviation from the answer, the question. In fintech, which is the area you asked the question, there's also a similar equation. Is it called the Black-Scholes equation, which looks like the Navier-Stokes equations? And there's a lot of money poured into solving that. There's data centers used to figure out how the market's going to move. Look, yeah, if you follow the money, then a lot of AI is simply following the money. We don't individually represent that money, but as a collective force, consumers, individuals, users, we do wield a lot of power. And when that power is unified, we can make changes. We can make changes that are culturally significant. That is what the Kwaai movement is all about. It's about turning the tide, the monopolistic tide, the oligopoly that's controlling the industry at the moment is just unhealthy. It's actually unhealthy for the industry. It stifles small to medium businesses from participating. It's a winner-takes-all mentality. As I said before, in the board game Monopoly, when one person owns all the wealth, it's game over. And we don't want that, do we? In fact, if you played the game Monopoly and it gets to that game over stage, you find individuals saying, oh, well, why don't you take these properties over here and manage them for me? Why don't I give you some money? Oh, that's outside the rules. That's outside the rules of capitalism. It's humans being altruistic. Kwaai is an altruistic intervention to right the ship. So, call to action, join Kwaai if you haven't joined already. Tell your friends to join Kwaai. Figure out how you can participate in this movement. It's vitally important. And if you don't, ask yourself, why am I not doing this? But anyway, we're going to have a chance to meet the speakers and mingle over some entertainment and drinks and nibbles at the Hotel Dana. There you go. Look forward to carrying on the conversation. Thanks, everybody.